Hi everyone, in this video we're going to solve all the questions for Maths B paper 2. Now in this file we have mensuration, we have probability, statistics and arithmetic, algebra, geometry and equation graph. Okay, so solving this entire video will actually help you to revise all the topics for IGCSE Maths B paper 2 that is going to be held on this Monday 10th of June, I guess, right? Okay, now before we start, we're also starting our A-levels trial classes, and also some crash courses are available for your IGCSE. For those of you who are sitting for your first session this in this May, and then again you guys have a second session in October 2024, we have crash courses available for IGCSE Physics, Maths B, Pure Maths Biology, and for ICT. So if you want to join any of the crash courses for the 5 subjects, please inbox us in our WhatsApp. Okay, and this is our WhatsApp number, or you can also email me in this email address. And for A-level classes, for those of you who are going to be done with your IGCSEs in this May June 2024 and start to continue with your A-levels from the next month for the May 2025 session, then we have our AS A2 batches open for May 25 session, and we're opening our classes for physics, maths, and also for A levels. IT is also available. So trial class will be on 20th of June. Okay. For those of you who does not know what IT is basically information technology, like the A level version of ICT. Okay, so we are opening a new entire class for IT. Those of you who already know, we also have a Dexel Easy ICT available, a Dexel Easy IT channel available, and you can obviously have a look on the IT section also. For those of you who are interested into programming, into engineering courses, I would suggest please try our trial classes for IT, and then you can decide if you want to continue or not. And otherwise, the trial classes for physics, maths and IT will be approximately held on 20th June for ASA2 batches for May 2025 session. And if you guys are interested, please inbox us in our WhatsApp or email us. Okay, these are the crash courses for IGCSEs October 24, and these are the year-long course for the entire session for the May 2025 for your ASA2 batches. I hope if anyone is interested, they would reach us through our WhatsApp or through email. So, okay, then let's start. Now, this question is from Jan 2022, paper 2. This is actually 2PR, not 2P. Okay, this is the R paper maths. And in this question, we're doing question 11, that is from mensuration. We can see we have a cone on figure 1, and we have a sphere in this part. And they're saying that figure 4 shows a solid right circular cone of radius r and height 3r and a sphere of radius 10. The total surface area of the cone is equal to the total surface area of the sphere. This time over here for cone they were using the word solid, like right circular cone, solid, right? That means in this situation the total surface area of the cone will not only have the curved surface area, well, and will also have the solid base, right? So it will be basically curved surface area plus the solid base. So for cone, the curved surface area is pi r l, and the solid base is a circle, pi r square. So before we start with the curved surface area, we need to find out the value for the slant length. This is the slant length. Let me just highlight this. This is your slant length. Right, this is your slant length, and obviously height is always perpendicular to the base, right? This is your height over here. And the radius is already provided r. Obviously, this entirely creates a right circular cylinder. I hope that's clear in general. This is the right circular cylinder's base. Now from this part, if I just take this out over here, I can clearly see I can now use the values for your height and base to get the value for your slant length um, for this cone over here. So height is 3r and base is just r, radius is just r. So I can use Pythagoras theorem over here. So it's going to be, I mean, obviously over here it's clear that this slant height is the hypotenuse for this right angle triangle. So it's going to be L square 3r whole square plus r square everything I mean, if everything under a root, then L will not have a square. So everything under a root, and you're going to get now 9 square plus 1 square. So eventually it will be like 10, 10 r square root, and r can be taken out of the root as it has a already power of 2. They will cancel each other out. Now you have just root 10 r, right? That is the value for your slant length. Now using the value for your slant length, they want you to find out the value for that small r to one decimal place, right? But before that, the volume for your sphere over here is actually not volume. Over here they are trying to find out the total surface area, right? Total surface area for the sphere is going to be 4 pi r square. Okay, so for this one, the volume, not the volume, total surface area is 4 pi r square, and for this cone, the total surface area this time will be pi r l plus pi r square, right? Now over here, this is going to be 1 minute. It was already stated that your total surface area for cone is equals to surface area for sphere, and this is going to be surface area cone, surface area sphere. So pi r l plus pi r square is equals to 4 pi r square. Now I already know the radius for your sphere was 10. So this is going to be uh, root 10 r, I mean root 10 r multiplied with r then pi, and then you have plus pi r square. This is equals to 4 pi 10 square, right? Now you have root 10 pi r square plus pi r square equals to, this is going to give you 100. So 400 pi. What I can do is that on the left hand side I can take r square common, so it will be, or I can take pi r square common. So I mean at the end you're going to get what, 1 plus root 10, that is equivalent to 400 pi, and obviously this pi and this pi will get cancelled out, and now you're left out with r is equals to 400 divided by 1 plus 10 root everything under a root. Now you do not need to give out the exact value, because in this part the question we're also asking you to give your answer in one decimal place, right? So it will be 400 1 plus root 10, and that will be 9.8, right? One decimal place. I mean that is a very big value that we get from a calculator, 9.803123448. So I'll just keep my answer to under one decimal place. So I am getting the value for your radius for that cone was 9.8. Maybe it was centimeters. 1 minute, yeah, 9.8 centimeters. So this is the value for your radius. I hope that's clear. Let's move on to the next question very quickly. This is not the next question. This is under the same year, same session, section B now, or part B now. Over here for part B, we can see a right pyramid. Figure 5 shows a right pyramid, and the base is A, B, C, D, E, F of the pyramid is a regular hexagon. This portion is a regular hexagon, and the vertex V of the pyramid is such that vertex V is this top section of your pyramid, and it is such that all these slant lengths AV, then AV, EV, and DV, BA, BV, and CV. Okay, all the 6 lengths over here are equal, and they have a combined, or they have a common length of 15 centimeter. And it is also stated that AVD is 40 degree. That means AVD over here, in between these two planes, the angle was 40 degree. We need to calculate the volume to in centimeter cube to 3 significant figures of this pyramid. Now the volume of a pyramid is what? 1/3 base area into height, right? That is the volume of a pyramid. Base area we can clearly understand. We have to find out the base area for this hexagon over here, right? Hexagon means that it will obviously create 6 triangles at the base, and each triangle should have like equal lengths. Let's just draw a hexagon over here, like this hexagon. Sorry, 1 minute. Okay, this is how the base would look like. Now for this hexagon over here, okay, now for this hexagon over here, I can understand this is A, F, B, C, D, E. Right, this is how it looks like. Now I can clearly create 6 equal triangles from this. So the 6 equal triangles are going to be, if I can connect B and E together, then E and F together, and lastly if I can connect A and D together. Okay, now this is how this entire hexagon looks like. Now they have what? You can clearly see 1, 2, 3, 4, 5, 6. 6 in total triangles under the base of this pyramid, right? And we need to find out the total area for this hexagon, or maybe I can easily calculate the area of my one triangle and then multiply it with 6 to get the total area of this hexagon. It was already stated that over here, if you can connect AB, that was already given, the length of this was 14, and VD, that was also 14, sorry, not 14, 15 centimeters. And if I can connect AD together, okay, and they are creating an angle of 40 degrees. From this part, I can easily calculate the angle of your, not angle, I can easily calculate the length of your AD base over there. If I then can calculate the value for your AD length, like the base of this will also be the length of this AD section. So if I can find out the length of this AD section, half of this will be, maybe I'm considering the center to be O over here, okay. That means, for example, I'm just giving you random values. If the total length for AD is like 12, in that case, AO would be 6, OD would be 6, right? Over here, these are all isosceles triangle, okay? All these lengths, OC, OB, OA, OF, OE, and OD, these are all equal in length. So what I can do is that I can use my concepts from the triangle AVF, so AVD, where the angle was 40 degree, and these lengths were 15 centimeters. I can easily use cosine rule to get the value for AD. So for cosine rule, the formula would be AD 15 square plus 15 square minus 2 15 multiplied with 15, then cos angle 40, and everything under a root. Right, now if you calculate the total value, this is going to be 10.3 approximately, okay. As this is not my final answer, let's just keep a very big value to continue with. So I'm getting 10.261, okay. So the value for your AD is 10.261 centimeter. That means now I can understand the half of this length would be the length for your AO, OD, OB, OC, and OF, OE, right. Let me just write this down, that OA, OB, then OC, OD, OE, and OF. Okay, they all have half of this length. So this divided by 2 will give you the total length for OA. Divided by 2, this gives you 5.13. Okay. Now from this part, again, if you just focus on just one triangle over here, okay, on this triangle maybe, now you have the lengths over here, the length for the two sides, OC and OB. This is going to be 5.13, and I can easily get calculate the value of my one angle. That is what, 360 divided by 6 will give you the angle for BOC, right? So from this part, I have to take this. Now I will continue with my working from here. I'll just keep it over here because this is related to this diagram. Now again, if I just focus on in triangle OBC, okay, in triangle OBC, the angle BOC is basically 360 divided by 6. So 360 divided by 6 obviously gives you 60 degrees. So this is going to be 60 degrees. So that means the total base area over here is going to be one area of one triangle is half AB sine theta. So half AB is going to be that 5.13 multiplied with sine 60 degrees, and we have total 6 equal triangles like this on the base. So it's going to be 0 0.5, 5.13, 5.13 multiplied with sine 60 degrees, and then you're going to multiply this with 6. Okay, that will give you the value for your total base area, which is going to be 68.4 centimeters square. Okay, that is the value for your total base area, 68.4 centimeters square. And that is not everything that we actually have to calculate. We also still have to calculate the height of this pyramid, right? We only have the base. According to our formula, the volume of this pyramid, okay, for volume the formula is 1 by third height multiplied with base area. We only got the value for base area, that is 68.4. Now we also have to calculate the height. For height over here, I can again use this triangle and just divide this like this in this format. And now at the very bottom over here, we already consider that to be the point O, right? So I'll just copy this and paste it over here again. And again for this section, if we only focus on maybe only half of the triangle, right? I already know OA, the value for OA was 5.13. Then I can easily use Pythagoras or sine cos tan to get the value for the height of the pyramid. So over here, if you focus on in triangle OAV, OV or height of the pyramid is going to be 15 square minus 5.13 square, everything under a root. So 15 square, 5.13 square, and that will give you 14.059. Okay, so I'm just trying to keep as much big value as I can. So 14.059 centimeter. So now I have the data. Now I have the area, base area. Now I have the height. So using this, I can easily input these values into your formula for pyramid to get the value, final value for your pyramid, which is going to be volume 1 by third height multiplied with base area, which is going to be 1 by third. Height was height was 14.09 multiplied with 68.4. And this is going to be 484.09. So 482.049 centimeters square. So centimeter cube. Right, but then again in your question they asked you to keep your answer in wait 1 minute. Maybe the answer for my area was wrong or something. 1 minute, let me just check. 13 into sine 60 degrees multiplied with 6. This multiplies with 14.09095 and then divided by 3. Yeah, sorry, I actually made a miscalculation over here. The answer turns out to be 321.2406 centimeter cube, but my answer should be in 3 significant figures. So it should be in 321 cm cube, right? That is your final answer now. Okay. Now if I move out or zoom out a little bit. Okay, so if I zoom out, this is how the entire maths was for this entire question 11. This was only for part B, and this was part A. So I hope this question was clear for all of you. We'll move on to the next question for mensuration. This is now from June 22, paper 2, question 8. Over here, we can see that figure 2 shows the design for a garden feature. In the middle of the feature is a circular pond, and the pond is surrounded by 6 identical flower beds. So each flower bed is in the shape of an isosceles trapezium. Okay, isosceles trapezium, and wait, the shape of an isosceles trapezium. Calculate the area in meters square to 3 a significant figure of one of the flower beds. Okay. Mm. Now over here they have provided you with, okay, this slant length of the trapezium is also given 0.9. So if I can just like make a separate diagram for the trapezium over here. Okay, now in this part, it was already stated that this line was maybe 12, 1.2 and 2.1. Okay, so this is 1.2 meter, and the base entirely from this part to the other end, that was 2.1 meter. So over here, if I can, take this red line, copy this and paste it again for the other section, that is in this part, I can clearly understand this portion is a rectangle. That means again the slant lines were a length of 0.9 meter. These are 0.9 meter, and this portion is going to be parallel or same length to the very top, which was 1.2. That means this portion is 1.2. At the end, this sides is going to be again of equal length, but we do not know the length for that section. So what I will do is that this entire 1.2 was actually divided into 3 sections. I'm going to consider this as x, this as 1.2, and this as again x. So I can easily calculate the value for that leftover extra section of the trapezium, which is going to be x plus 1.2. That will be equals to 2.1 meter. Now we have 2x, so eventually x will be 2.1 minus 1.2 divided by 2, and if you calculate this, you will get the value for your height of the base of the trapezium, which is going to be 2.1, 1.2 divided by 2. This gives you 0.45. Okay, now we have 0.45 meter. Now in this part we can clearly understand this portion over here creates a triangle. For this triangle, if we use Pythagoras theorem, we can easily get the height, and using the height we can easily understand, or we can easily find out the area for this entire trapezium, which was actually the area for one flower bed. So we are now going to find out the height. This is your height, and height is basically under a right angle triangle, right? So now height is actually 0.9 whole square minus 0.45 whole square, everything under a root. And this is 0.779. The height over here turns out to be 0.779. Okay, this is 0.779. So the area of your trapezium formula was half AB sine theta. So you have AB height over here. So in that case, area for one flower bed, this is going to be half 1.2 multiplied with 2.1 multiplied with 0.779, right? Half AB height, and you're going to get the final answer is 0.9827. And wait 1 minute, let me just recalculate. 0.779, 0.5, 1.2, 2.1. Oh wait, sorry, made a mistake. Actually, I was multiplying these values. Sorry, I was supposed to add these values, right? For trapezium, I was supposed to add these values. Okay, so you're going to get 1.28535. So the final answer should be in three significant figures. So I'll just write 1.29 as your final answer for the area under one bed, flower bed. So 1.29 meters square, right? That is your final area. So this is it for part A. We're going to move on to part B. Now for part B, now it has stated that each flower bed needs to be filled with compost to a depth of 10 centimeter, and thus compost is sold in bags containing 50 liters of compost. Okay, show that 16 bags of compost will be needed to fill all 6 flower beds at a depth of 10 centimeters. We need to show your working. Okay. Now over here, as the compost were given like in each bag there were like 50 liters of volume, right? The compost will be in a volume of 50 liters in each bag. So I would have to find out that what would be the total volume for these 6 flower beds over here. I mean, I can easily understand for a trapezium case over here, this is going to be create a like um, a pyramid, like a prism over here, like trapezium prism. So for this trapezium prism, we can easily calculate the volume. That will be basically the base area into height multiplied with 6, because you have 6 similar trapezium prisms over here in the form of a flower bed. So height was already given 10 centimeter. You have to obviously convert that into meters, because every other length was given in meters, right? We also calculated the base area in part A in terms of meters square. So height obviously has to be converted to centimeters, like from centimeters to meter. That is basically 100. 10 divided by 100, that turns out to be 0.1 meter. That is the value for your height. And now using this for part B, we can easily find out the total volume of the flower beds first. That is going to be height was 0.1 and base is this 1.29 multiplied with 10. Sorry, 0.1. 1.29 with 0.1 is 0.129 meter cube. Okay, now this is the value for meter cube, but again remember in a question the volume of the compost in each box was given in terms of liters, that in every compost you had 50 liters of compost in each bag, right? So you have to then convert liters into again meter cube to actually find out that how many bags will be required to actually find out the total area. Also, one thing, I again have to multiply 6 with this because I want to find out the total volume for all the flower beds, right? And we have same 6 beds, flower beds. So the final volume is 0.774. Okay, now when I have to convert this meter cube into liters, so that will be 1 meter cube is actually equals to 1000 liters. That means we have 0.774 meter cube. That will be equivalent to 1000 multiplied with 0.779, right? So it is 0.77, sorry, 4. 0.774 multiplied with 1000, and that is 700 74 liter. Now I know that one bag contains 50 liters and I at the end have to fill up this total 774 liters of land, right, with that compost. So I'm going to use unitary method this time, that if 50 liter is for one bag, then I have total 774 liters that need to be filled out. So at the end, I just have to divide this 774 over 50, and you're going to get 15.45 bags. Now, bags over here cannot be in fractions, right? So, I mean, I have to use what? 15 plus 0.45 bags. I cannot buy 0.45. So, at the end, I have to buy 16 bags in total. So, this is going to be that I have to buy 16 bags. This is to the nearest whole number, okay? I mean, for bags, I cannot buy fraction of bags. The shopkeeper will not sell me a 0.45% of the bag, right? The shopkeeper will sell me the entire bag. So this is to the nearest whole number. Okay, now that is the working for your part B. After part B, if we move on, for part C now, they are saying that find the area of the circular pond also and give your answer to like meter square and three significant figures. Okay, for this circular pond over here. Now, for the circular pond, they have not provided you with anything, any informations, right? 1 minute. Find the area of the circular pond. In the middle of the feature is a circular pond. Okay, let's just try to create some lines over here. For example, if I create the opposite ends, now we cannot actually find out the area of the of this circle using this part of distribution, because if I'm going to draw the lines in this according to the diagonals, then this portion was not actually in part of your circle, right? There was this small portion that was not a part of your flower beds or not a part of your circular pond, so we cannot actually do this in this format. What I have to do is that I will remove this lines and I will connect the lines in this procedure. As you can clearly see for these sections over here, for these sections, the entire circle was coinciding with the one parallel side of your trapezium, right? So this is like a tangent for your trapezium now, or for your circle now. If I can connect all these together, this is how it looks like. And using this concept, okay, now again for this part, I can also just maybe draw one line over here. Okay, now in this portion, if you just focus on this triangle, okay, from this triangle, remember, in order to find out the area of your circle, right, you need to find out the radius only. By calculating the radius will give you the total area for your circle automatically, because area of a circle is what? Pi r square. The only unknown alphabet for area information is the radius. You just have to find out the area. I mean, you just have to find out the radius first, and using that you can easily calculate the area of a circular pond. Now in this section over here, I can clearly understand I will label this center as O and this point as E and this point as F, right? So if I can make a very short image of OEF over here, this is entirely a right angle triangle, I can understand that, where OE will be the radius, because this is from what? Center to the circumference, right? So OE becomes the radius of the circle. Base is going to be half of this 1.2, because total length was 1.2. So half of this would be 0.6. So this is 0.6. And again, the total angle for this part was like 60 degrees, right? If the total angle was 60 degrees, half of this will be um, yeah, half of this, right? Yes, half of this will be 30 degrees now. So in that case, is it 30 degrees? 1 minute. Let me just draw the hexagons again. And this was one portion and they were creating 60 degrees, right? 360. Wait 1 minute. Let me just connect this last line over here. Okay. Now this entire thing was 60 degrees, so half of it would be like 30 degrees then, right? Because you have 1, 2, 3, 4, 5, 6, right? So 360 divided by 60 should give you 60 degrees. And I think we used that somewhere. 1 minute. Oh no, not for this triangle. We used that for the previous maths. Sorry, my mistake. Wait, 1 minute. 360 divided by 6 is going to be 60 divided by 2. That's 30 degrees. So you have 30 opposite adjacent. So opposite over adjacent is supposed to be 0.6 divided by tan 60. Yeah, this will give you the correct answer. Okay. Now, if you focus previously, I would have to like what? Slice this entire trapezium is entire, not trapezium, entire this circular bead and whatever the structure is into 6 portions to find out one interior angle. And we can clearly see this will be like what? Half of one interior angle, right? Because this portion would be for one total interior angle from the center to the other side of the trapezium to the other side of this hexagonal trapezium end is going to be 60 degree and half of this is going to be 30 degrees over here. So in this portion, we are going to get the value of your theta as, I'll consider calculating that as a part of your working. So theta is basically going to be 360 divided by 6. That will give you the value of your total this portion of the angle. And then again you have to divide it with 2 to give you half of this one slice, right? So this gives you 30 degrees. So now you have the value of your theta as 30 degrees. So you can use sine, cos, tan. I mean, over here I have to use tan to find out the area of your r. So it will be tan 30, 0.6 divided by r. So r would be 0.6 divided by tan 30 degree. If you calculate that, then you get the value for your r as 3 root 3 over 5. Okay, that is the value for your radius. Using the value for your radius, you can easily calculate your area now, which is going to be pi r squared, right? So I will just take this over here. And this is your entire working for your part C. Okay. So for the area, circular pond area, that will be pi r square, which is going to be pi 3 root 3 5 square. And if you calculate this and keep your answer to 3 significant figures, you are going to get 3.39 meter square. Okay, that is your working for part C. Okay. I hope this was clear for all of you. This was the working for question 11. So question 8 from June 22, 2p. Okay, this was one question from mensuration. I hope this one was clear. Let's move on to the next question. Next question we have from Jan 23 paper 2. This is question. Now we can see this is again a prism. This is a solid right angle triangular prism. Okay. Now over here solid means that in this case the base will also be considered when we would have to find out the total surface area for this structure. Okay. So we have this FGHIJK in which this corresponding lengths are given, that FG is 12, so FG is 13. 1 minute. FG is 13, FH is 12, and then IJ is 5, and HI is 20. And the faces of FHIK and GHIK of the prism are rectangles. Okay. Sorry, wait, what? FHIK, 1 minute. Wait, FHIK are rectangles. And GHIK is possible. GHIJ is this one. They're talking about this one is a rectangle. And if H, for this one, if KGH is a rectangle, right? But they are saying that this FHIK, oh sorry, the base over here, FHIK, these are also rectangles. And but then again, this one, FKJG, this is also rectangle, right? This slant structure over here, this is also going to be a rectangle. We need to find out the total surface area of FGHIJK. Okay, now from this part, I can understand what are the lengths for all the corresponding sides. First, list down that. For example, FG and this KJ will have the same length. So FG and KJ have the same length, 13 centimeter. This IJ and GH will have the same length. So IJ and HG is going to be 5 centimeters. Then again this HJ, GJ and FK, okay, they all have the 20 centimeters length. So HI and FK and GJ is 20 centimeters, and then FH and KI is 12 centimeters, and this is it. We have found out the length for all the corresponding sides, this and this, right? All the corresponding sides are found out. Now let's find out that how many structures they have. They have two triangles, which is FHG and KIJ. They have three rectangles, which is the base FHIK. Then this face over here, vertical rectangle, which is GHIJ, and the slant one over here. This is also rectangle FKGJ. Now, these are the five structures which are combined together to get this solid right angled triangular prism. Okay, now for this part again, let me just go back to this portion. 1 minute. Now for that FHG, right, I can easily calculate the value for my GH is not, no, we do not need to find out the value for GH, we already have that is 5. So base into height, half into base into height will give you the area for this triangle, and multiplying it with 2 will give you the area for the two triangles over here. So now it will be, wait 1 minute, yeah, that will be the case. For the triangles, if I just draw the triangles over here, for FHG, this was 5, as you know, this HG was 5, and the base was FH, which it was 12. So I can easily get the area for the triangles. That is going to be half 12 multiplied with 5, then again multiplied with 2, because you had two similar triangles like this, right? So this is going to be just 12 into 5, that's just 60. Sorry. 12 into 5, that's just 60. Okay, so then again we have three rectangles. For the three rectangles, now the rectangles are different. If we focus on FHIK, for this FHIK, now see this, that FH has a length of 12, that means IK will also have a length of 12. FK has a length of 20, and HI also have a length of 20. Now over here, this one will have an area of 20 multiplied with 12, that will be 240 meters square, right? And then again, if you like, this one is calculated, this one is calculated, this one is calculated. If Let's move on to GHIJ. Okay, for GHIJ, this vertical one, GHIJ, this is GHIJ. For GH, the length was 5, IJ was also 5, HI is 20, and GJ is also 20. Now for this particular triangle, the area would be 5 into 20, that is 100 meters square, right? Then again, if I just as I do not have space, let's move on to the next space, and then we still have another area to calculate, right? For example, we calculated this, FKGH is still left over. So this FKGH This is F, then we have K, then G and J. Okay, for FG this time, FG is 13, we can understand that. FG is 13 and FK was 20. Okay, so that means FK is 20, that means GJ is 20 and KJ is also going to be 13, right? This is 13. So this now it's going to be 13 multiplied with 20. So which is 13 with 20, that turns out to be 260 meter square. At the end, for the total surface area now, this, this and this. You just have to add all these things to get the total surface area for this trapezium, for this right angle triangular prism, right? So now I can write that total surface area is just 60 plus 240 plus 100 plus 260. That is 60, 240, 100, 260. 60, 40, 60 to 40, 100 to 60, which is going to be 660. Okay, that is the value for your total surface area, 660 meters square, and that is for part A. Okay, now after this, if we move up, this was the entire working for part A. Let's move up. Calculate the size in degrees to one decimal place at FJI. Okay, so for FJI, they want to find out the angle in degrees for FJI. For this FJI, let's connect the structures over here. So FJ is going to be the diagonal of that rectangle, and this is JI, and FJ is also going to be the diagonal of the rectangle in the base, right? Which was FH IK, that was the rectangle. Now this is how this entire thing looks like. We need to find out the angle over here at FJI. Okay, so if they are talking about FJI, that means this is where your angle should be. Okay, now calculating this FJ, we cannot calculate that easily, but we can calculate FI by calculating the diagonal of the base rectangle. Now in the base rectangle, we had FHIK, right? This was FH, sorry, this was FHIK, and then I can easily connect F and J together. F and I together, that will be the base of this FJI. So this is going. This was 12, and this was 20, and this length is obviously the hypotenuse over here. I can clearly understand. So Fi is going to be 12 square plus 20 square, and everything will be under a root. Right now, this time it will be 12 square plus 20 square. This is going to be 4 root 34. Okay, 4 root 34. That will be the length for your Fi. Right. Now again, now as I have the length for your Fi, if you focus on this triangle, okay, on this triangle over here, this is, by the way, Fj is actually not on the rectangle FKGJ. That is entirely in between the right angular triangular prism. Okay, this is like in between the prism, from the other end to the other end they're connecting. It's not going to be exactly on this rectangle. Okay, this is like a in between dissection for this right angle triangular prism. Now over here for this part again, if you want to calculate the angle over here, I can clearly understand this one will create 90° as Fi was in the base and Ji was in the vertical height. So this is obviously 90°. Now this one we calculated to be 4 root 34, which is the opposite, and height is already given 5. Like over here the adjacent is obviously given, so I can easily use Pythagoras. So the Pythagoras, I can use sine cos tan to get the value for this angle, right? So I can easily calculate if Ji, which is going to be tan inverse, on opposite we had 4 root 34 divided by, on adjacent we had 5, right? So this is going to be tan inverse 4 root 34 divided by 5, 4 root 34 divided by 5. And if you calculate that, then the angle turns out to be 77.9 degree. Okay, so 77.9 degree. So this is the value for your angle. Now if I just move down, this is A, this was for B. Okay, this was the working for B. Now let's move on to part C. Okay, for part C now, a company makes door wedges the same size and shape as the triangular prism. If GHIJK, the company packs the door wedges into boxes that are in a shape of a cube of 60 centimeter. Like, I'm going to fit as much wedges as I can inside a box of a cube shape, and obviously cube means that all the diagonals are going to be of same, like all the dimensions for this cube are going to be of 60 centimeters. And we need to find out that exactly on maximum how many wedges can we can fit into that cube box of dimension 60 centimeter. Again, we have to convert that 60 centimeters into, no, we do not need to convert that because uh, all the lengths were given in centimeters also. So I think I made a mistake. All these lengths were supposed to be in centimeters, right? Really sorry. These were supposed to be in centimeters. These are supposed to be in centimeters. Now, for part C, I can obviously understand that one volume will, I mean, over here I can easily calculate the volume for this, what is this, wedge over here, that is basically cross-sectional area into height, right? Over here, the cross-sectional area will be the area of this triangle and height is this 20. So I can easily find out the area, volume of this triangular prism, and using that, I can use unitary method to find out that how many number of wedges I can fit in inside whatever the volume for that cube would be. So let's just find out the volume of cube or that box first. So volume of box, that will be 60 centimeters, 60 centimeters, 60, 60, 60, right? That's just 60 cube, which is going to be 216,000 centimeter cube. That is the volume for one box. And let's find out the volume for one wooden edge. That is going to be again base area into height. So base area into, yeah, base area into height. So base area was 30 then, right? For one, yes, for one base area it will be half of this one we calculated, because this was for two triangular places over here, right? It had two surface triangular faces, so we had to multiply two. That means over here, if you want to find out the triangular face, that is just going to be 30 degrees. So I can just write half 15, 15. So I have 12 to half 12 5, and this will multiplied with 20 base area into height. So half 12 5 and then 20, you get 600 centimeter cube. That is for one volume. Now I can write that if for 600 centimeter cube I get one wedge, that means for 216,000 centimeter cube, I'm supposed to get 1 over 600 multiplied with 216,000. Okay, so that's 216,000 divided by 600, which is going to be 360 wedges. Okay, so inside that box, I'd be able to fit in 360 wedges of similar volume. So this much wedges. Okay. That is the working for your part C, by the way. I'll just keep this part C over here. No need to take it to the very bottom. Okay. Now this was it for the part A, B and C for this Jan 23 question 9. I hope this was clear for all of you. Now let's move on to the next question. This is again from Jan 23, question 4. This is mensuration and shading, and also something about, sector areas involved over here. So in this part, they're saying that There is a circle with center O and radius 3.8. The points A and B lie on the circle and C is such that AC and BC are tangent to the circle, and it is also given that if you're going to like extend the tangents and meet them, the angle ACB is going to be 70°. We need the region inside the quadrilateral of OACB but outside the circle. This portion they're talking about inside the quadrilateral but outside the circle is shaded in figure 3, and we need to find out the area in centimeters square to three significant figures for this shaded area. Okay, now I already know that tangent and radius are always what? Perpendicular, right? So I can easily get the angle for this part, which is going to be 360 minus 90 minus 90 minus 70. That will give you the value for this portion. And then again, I can actually consider over here this OAB as a sector. Right, I can consider this portion as a sector, and then again, if I can find out this area, I need to also find out the area under the total trapezium. Okay, for the total trapezium, I will just like take this out. For the total trapezium, I can consider this as two right angle triangles, because over here we are getting 90 degrees. Right, then over here I am getting 90 degrees, and each angle for this section would be what? 35. Right, I already have the base, so using that I can also calculate the height over here. This is going to be the height, and then further I can find out the total trapezium, which is going to be half base into height multiplied with 2, because now you have like similar two triangles. This is triangle 1, this is triangle 2, and then if I can subtract this sector out of this trapezium, I can easily get the total shaded area. Right? That is my entire procedure over here. So let's just first find out the angle, right? The sector angle over here. For the sector angle, I'm actually using the concepts of a trapezium. For the angle theta, which was angle BOA or AOB, whatever you consider that to be. So in that part, I'm considering, or I'm focusing inside the total trapezium. Okay. So or quadrilateral. In quadrilateral, that was OABC, right? Or sorry, OACB. OACB angle AOB is supposed to be 360° minus 90 minus 90 minus 70. This is going to be 360 minus 180 minus 70, and that turns out to be 110 degree. So now I can easily find out the area of the sector AOB, which is going to be what? Theta by 360 pi r square. So theta is, this is 110. 110 by 360 multiplied with pi. Radius is already given. Radius was 3.8 centimeters. So 3.8 centimeters square. So 110 by 360 multiplied with 3.8 square with pi. Okay, theta by 360 pi r square, and you're going to get your value as a very big value, but I'll consider to take it as 13.86 centimeters square. Okay, so this is 13.86 centimeter square. And now again, after this, I can easily calculate the area of my entire quadrilateral also, OABC or OACB. Now in this part, I can easily calculate, if I just focus on OBC, for OBC in triangle OBC, angle OCB is going to be 35°, half of that 70, and now BC will be like what? Opposite over adjacent, right? Adjacent was BC, so BC in that case is opposite was 3.8, which was OB, divided by opposite over tan 35. So you're going to get 3.8 by tan 35, and which is 5.43. 6.43 centimeter. So now you can find out the area of the total quadrilateral. So area of quadrilateral OACB is just going to be half multiplied with base is going to be 3.8, height is 5.43, and then again multiplied with 2 because you have two right angle triangles creating that quadrilateral. So 0.5, 3.8, 5.43, 2, 0.5, 3.5, 5.43, 2. So you're going to get 20.634 centimeter square. And then again lastly, to find out the shaded region, you just have to subtract this area 13.86 from 20.634 to get the shaded region. So 20.634 minus 13.86, and you're going to get your final answer as 6.774. So I can just write 6.77 centimeter square. Okay, that is your final answer then. 6.77 centimeter square. Okay. So I hope this question was also clear for all of you. This was from Jan 23 question 4 paper 2, and this is the entire working. So we'll just move on to the next question then. Now this is from again Jan 23 paper 2 question 3. Over here we can see that this shows a hexagon ABCDF in which they have provided you that the length BC is 3x plus 5, AF is 3x plus 2, and DE also 3x plus 2, and FE is 3x plus 21, and BC is parallel to BC is parallel to FE, and AB is equals to DC. Sorry, AB, 1 minute, AB is equals to DC. Okay, these two lengths are equal, and the perpendicular distance from between BC and FE is 3x plus 17. The perimeter of the hexagon is 172. We need to find out the value for x over here. Okay, now in order to find out the value for x, right, I can actually use this part. Since the value for my AB and DC were missing, right? So I need to like find an expression for them also, and then I can start working with the total pyramid concept, sorry, perimeter concept. And then I can start using that perimeter part as my hint over here. Okay, now in this section, if you just focus on this portion of the triangle, right, this portion of the diagram, this one entirely creates a triangle, and using this triangle, I can calculate the value for, or find an expression at least for the length for AB over here. The length for AB now, I can understand that since they have already provided me that BC was in parallel with FE, so I can considering these points as XY, which means that over here, xy will also be that equal length of BC, that is 3x plus 5, right? So first thing I can write that xy is equals to BC, and they both have a length of 3x plus 5. The total FE was 3x plus 21, but we do not know the actual length difference for fx and ye. So I can get the idea that fx and ye, they all have the same length again. So I'm going to consider that fx and not x over here like this, fx and ye plus your xy, three of them, if you add them, then you're going to get the total length as fe, right? That will be equals to fe. So using this, now I can easily calculate the length for my fx and xy, which I am considering, or I am assuming as fx and ye as m over here. Okay, this is my assumption. Now using this, if x is going to be m, ye is also m, xy is I already know 3x plus 5, and this should be equals to fe. Fe was 3x plus 21. So now with this part it becomes 2m, like m plus m is 2m. If you take this 3x plus 5 to the right hand side, this one becomes 3x plus 21, 3x minus 5. So we can clearly understand this 3x and 3x cancels out. 21 minus 5 turns out to be 17. Right? 21 minus 5 turns out to be 17. So 2m over here is, wait, let me just check. 21 minus 5 turns out to be 16, sorry. So in that case, m turns out to be 16 over 2, which is 8. Right. Now using this 8 over here, that means this portion is also, this purple portion is also going to be 8. And if this portion is 8, again I can consider that this point, I'm considering this as S and this point as T. Right. Which means that, wait 1 minute. Right, which means this, if total length is 3x plus 17, and if you just subtract this from 3x plus 17, you will get the length for this BS, right? So for that BS, I can create an equation again. For BS, I'll just subtract this, eliminate this. Wait 1 minute. For that BS, now I can like find out an expression for BS that will be just 3x plus 17 minus these lengths, 3x minus 2, 3x minus 2. So again I will just take this to the very bottom. Now this one turns out to give me as 3x plus 17 minus 3x plus 2. So we can understand 3x gets cancelled out and you left out with 17 plus 2 is 19. So take it to 19. Right? 19 over here. So this BS is now 19. Okay. Now since you have the value for BS as 19 centimeters, right, then again now you have this as Pythagoras theorem, right? So if you focus on BSA on your diagram, this is how BSA looks like on your diagram. This was B, this was S, and this was A, right? Always remember that FX and AS are of equal length, right? And YE and TD are also of equal length. So I can write that FX, YE, AS and TD, they are all of equal length of 8. That means this is 8 and BS was 19. Using this, I can easily use Pythagoras to get the value for my AB. So AB in that case will be 19 square plus 8 square and everything under a root, right? So in that case, this one turns out to be 19 square plus 8 square. This is now 5 root 17. Okay. Wait 1 minute. Sorry, made a mistake. This was actually positive. Okay, if that was positive, then this is supposed to be negative, and 17 minus 2 turns out to be 15. Okay, if this is 15, then these values would change a little bit. 15, 15. Okay, now you're going to get the value as 1 minute. Let me just calculate. As 17 only. This is not anymore 5 root 17. So this is 17. Now you go back to the concept of using the total perimeter for this structure was 172. Using that concept, you can actually find out the value for x. So over here, the total perimeter will only add or will only have this AB, right? AF, this total FE, DE, CD and BC, right? Only these 6 sections will be added to get the value of your total perimeter. So for perimeter now, I can add, I'll start with AB. plus BC, then CD, then DE and EF, and lastly AF, right? That will be the total. So let me just place this over here. Plus AF, that would be equals to 172 over here. And then again AB is what? AB I got as 17, right? Then BC was, if you move up, BC was 3x plus 5. So 3x plus 5. CD was again 17. Then DE was 3x plus 2. Okay. If E was 3x plus 21, and then lastly AF was again 3x plus 2, and these were all equals to 172. So from this part, if you just count the number of whole numbers and add them, that is we have 117, 17, 5, 5, 2, 21, 2. 17, 17, 5, 2, 21, 2. You get 64 and you have 4, 3. So it is going to be like 12x plus 64, 172, and at the end x turns out to be 172 minus 64 divided by 12. So 172 minus 64 by 12, that is 9. That means your final answer for x over here is 9. Okay, that is your final answer for x. Okay, I hope this was clear for all of you. This was for Jan 23, paper 2, question 3. I hope this was clear. Let's move on to the next part or next question. This is from again Jan 23, paper 2, question 2. I think for Jan 23, most of the questions was entirely about shaded region or about this mensuration concept. Okay, now for this part again, they have, I mean, over here, I think they're using similarities mostly. They have provided that the point AD lies on AB and E lies on AC such that DE and BC are parallel. Okay, this and this are parallel. They are saying these two vertical lines are parallel, and they have provided with you lengths that AD is 8, DE is 3, and they have provided you with ratio again that AE is to EC is 1 is to 2, and this angle and this angle is a 90-degree. So we need to find out the area over here. Okay. Now using Pythagoras theorem, I can easily calculate the value for your AE, and then again using this ratio for AE, I can easily calculate the length for AC. Right, over here, what I would actually have to do is subtract this small triangle AED, this small triangle from the big triangle over here, that is ABC. Okay, I just have to subtract that small triangle from the big triangle. That is my only work. So before we move on to your big triangle calculation, I cannot start with that. I need to start with my small triangle AED. This is A, this is D, and this is E. This is 3 centimeters. AD was 8 centimeters. And we need to calculate the length for AE, which is going to be easy for Pythagoras theorem. So AE turns out to be 8 square minus 3 square, everything under a root. Sorry, 8 square minus 3 square, which is root over 55. Okay, that is the value for your AE. Using this AE, I can now use the ratio concept to calculate the value for your total AC. Okay, I do not need to find out the value for EC. Okay, I need to find out the length for your total AC. Again, one thing, if AE was correspondingly to given a ratio of 1 and EC was given a ratio of 2, that means the total ratio over here is going to be 3, right? 1 plus 2 is 3. So over here, if you want to find out the total length for AC, this is going to be AC divided by AE. Corresponding AC's ratio was 3, AE's ratio was 1. That means 3 times the length for AE would be the total length for AC. So AC is 3 multiplied with 5 root, which is just basically 3 root 55. That is for AC. Using this AC now, I can easily calculate what I can calculate. 1 minute. This is AC, right? Base height. I can easily calculate. No, I still cannot calculate anything. Then I think I have to use similarity to find out the the height over here, BC. I can clearly understand these two triangles are similar, as they also have a similar ratio for their base, 1:2. Right? So I can use the like base length to find out the height over here. So for this similarity now, I'm going to write BC divided by DE, and that would be equals to AC divided by AE. So it is going to be BC divided by DE. DE was 3 centimeters. AC again was as 355 divided by 55 root. And this turns out to be that obviously this will get cancelled out, and this 3 will be multiplied with the 3 on the right hand side. So at the end you're going to get the length for BC as 9 centimeters. If BC is 9 centimeter, I can again calculate the value for your total triangle ABC easily. So area, I just have to find out the shaded region, right? For that shaded region, I just have to subtract ADE from ABC, right? So triangle ABC minus triangle ADE, which is going to be half. Base for this ABC is what? AC and BC, right? AC was 3 root 55, BC is 9. So this is 3 root 55 with 9, and then again minus half. For this, the base was root 55 and 3. So root 55 with 3. So if you just subtract them, and that will easily give you the value of your total shaded area. 0.5 multiplied with 3 root 55 with 9, and then again minus 0.5 root 55 with 3. That turns out to be 12 root 55, or approximately 88.99. But then again, I think our answer is supposed to be in two significant figure. That turns out to be 89. So in accurate exact value is 12 root 55, and to two significant figures, this is 89 centimeter square. Okay. This is the entire working for question 2 of Jan 23 paper 2. I hope this one was clear for all of you. Let's move on to the next question quickly. This is from Jan 23 2PR. We have a cone over here, we can see. For Jan 23 2PR, it has a right circular cone, and the radius of the base of the cone is 8 centimeters. The volume is 320 pi. We need to find out the total surface area in K pi centimeter cube, and then calculate the value for K. Okay. In order to calculate the value for K, basically, you just have to find out the total surface area. For total surface area of a solid cone, I know the formula is pi r L plus pi r square. But that L is missing over here, right? So we have to find out L, but then again, L has to be found out using height, and height has to be calculated out of this volume. So you have to first start with volume formula. So volume is given as 320 pi. For this cone, the volume formula is 1/3 pi r square h 320 pi. I can clearly understand pi will get cancelled out, and r is already given 8 square. So h over here turns out to be 320 multiplied with 3 divided by 8 square, that is 64, right? So now you have 320 with 3 divided by, square divided by, no, sorry, that was not supposed to be on square. 8 square. 320 multiplied with 3 divided by 8 square turns out to be 15. So you get your height of the cone as 15, And then I already understand that the height, radius, and the slant height always creates a right angle triangle for a cone, right? This is your radius as 8, height as 15, and this is your slant length. So I can easily calculate the slant length as 15 square plus 8 square, everything under a root, and that will be 15 square plus 8 square, which is going to be 17 again. So if the value for your slant length is 17, so using this 17, I can easily now calculate the total surface area. Every other unknown quantity has been calculated. So now total surface area of cone is pi RL plus pi r square. So pi 8 17 plus pi 8 square. So this is going to be pi 817 plus 64 pi, and you're going to get it as 200 pi, right? Again, in your answer you're supposed to give your answer in 200, like in k pi centimeter square, right? Now we can understand that the value for k would be 200 only, right? So you can just write that the value for k, because this was always equivalent to k pi, right? K pi, and obviously the pi get cancelled out, and now you're left out with k equals to 200. That is your final answer for Jan 23 paper 2 question 3. I hope this was clear for all of you. We'll move on to the next question. This is again from Jan 23 2PR question 5, and this is also for trapezium. For this trapezium now, it says that this figure shows a right triangular prism ABCDEF, and they have provided you with dimensions that AB is 5, DF, so DF is 8, and AF is 7, and also CBA is 90 degree. Calculate the volume in centimeters squared, the nearest whole number for this triangular prism. Okay, I can understand that if AB is 5, CA and DF both are 8, right? Using that, I can calculate the height, and that will be easy for me to calculate the area, as ABC is the cross-sectional area, right? And cross-sectional area multiplied with height, this is 7, will give you the volume easily. So for this part, I have to first write that CA is equals to DF. They are both 8 centimeters, and now I can find out CB, that will be equals to 8 centimeters square, like 8 square minus 5 square, everything under a root. If you calculate that, you're going to get as 5.13. Let me just check 1 minute. Right. This is root over 39. Okay, this is 39 root. Now you get the height and base, right? Using the height and base, easily you can calculate the cross-sectional area and then multiply it with height. So for the volume now, half, base is 5, height is root 39, and multiplied with 7, right? Half into base into height with length. So half into 5 into root 39 into 7, half into base into height with 7. And that will be approximately 109.287, and to the nearest whole number, this is going to be 109. Okay. 109 centimeter cube. So this is option A. And let's just keep this over here. No need to drag it to the down. And now in this part, you can see that the figure 3 shows a shaded shape made by removing a triangle PTQ from this rectangle PQRS. And they've also given you with dimensions that QR, where is QR? QR is 12, SR is 25, and PTQ, this one is 90 degrees, and TQR is 20 degrees. So you need to find out the perimeter in centimeter to the nearest whole number. Okay, for this perimeter, I can understand that if this is 12, this is also going to be 12 PS. We just have to find out that length for PT and QT. Before that, let's just connect PQ together. Okay, now this is how the triangle would look like for that. Now this is how the triangle would look like for that PTQ, which was actually removed from this structure, from this rectangle. And yeah, if this is 25, in that case, this PQ would also have been 25. Okay, and what else? We can understand that this total angle was 90, right? If this total angle was 90 and this portion is 20, we understand that this angle PTQ is actually 90 minus 20. This is 70 degrees, right? Using this angle and 25, I can easily calculate the length for PQ and TQ, right? So for example, over here, I have to first write this down, that how did I calculate the length of PTQ? So PQT. For part B now, angle PQT is basically 90 minus 20 degree, which is 70 degree. And using this 70 degree, now I can find out PT and QT. For example, for PT, this PT now is the opposite, and PQ was the hypotenuse, right? Right. So I can use opposite over hypotenuse, and I can use sine over here to calculate the length for PT. So for PT, I can use sine 70 degree. On opposite, you had PT divided by adjacent was PQ, which is going to be PT, as PQ was 25 multiplied with sine 70. That will give you the value. So this is 25 sine 70. 25 sine 70 is a very big value. Let's just keep it over here like this, okay? And then again for QT, I can also do the same procedure. For QT, I would have to use, this is now going to be adjacent over hypotenuse, so I have to use cos for QT. So again, this is cos 70 degree. Adjacent was QT, hypotenuse was again PQ. So QT is going to be 25 multiplied with cos 70. Then again, if I calculate this, this will be a very big value, so no need to exaggerate that. Now I have the length for all of the dimensions. PS, SR, QR, QT, PT, all of the dimensions are now known to me. So I can easily use those values and calculate the total perimeter for this structure. So for perimeter over here, PS, SR, QR, PT and QT. So for PS, it was 12, SR was 25, QR was also 12, PT was this 25 sine 70 degree, and then again the other one was 25 cos 70 degree. So if you just add all these values, you'll get the total perimeter for this structure. 12, 25, 12, and then 25 sine 70 plus 25 cos 70, which is going to be 81.04 something, but according to the nearest whole number, I think to the nearest whole number, answer would be just 81. Okay, so this is 81 centimeter only. This was the working for part B. I hope this was clear for all of you. Let's move on to the next question. Okay, now this is from November 23, paper 2. Okay, from this part, we have a kite and the dimensions of the kite are given. It is also given that AB and BC is equal in length, but they have different expressions, right? 6y, 2y, 6x, 2y, 10, and then 3x, y, 1. Okay, and AD and CT is also given. We need to calculate the length in centimeter of the perimeter of this kite. Okay. We can use this concept over here that AB is equals to BC. For example, if A is actually equals to BC, then I can write that AB, which was 6x plus 2y minus 10, is equals to your 3x plus y plus 1. Over here, if I take all the alphabets together and all the numbers together, you're going to get 3x minus 6x, sorry, 6x minus 3x, then 2y minus y, and then 10 plus 1. So now it will look like 3x plus y is equals to 11, right? That is how the expression would look like, 3x plus y equals to 11. And using this, I can, you usually do substitution over here to get the value for y and also to get the value for x also. So I consider this as my equation 1, and wait 1 minute. This I can take this as my equation 1, but 3x plus y plus 11, and what else? And then I already know that as this is a kite, right? That means if AB and BC are equal, that means AD and DC would also be equal to each other. So using that concept, that AD is equals to DC. Over here for AD, I had 2x plus 9y minus 14, and that will be equivalent to 5x plus 5y minus 9. Now, which is going to be 5x minus 2y plus 5y minus 9y, then minus 14 plus 9, and it will be 3x minus 4y equals to minus 5, right? This is our equation 2. Now I can easily do simultaneous equation over here to get the value for my y and x. Now I would do elimination over here because it will be easier for me to do elimination, as the y's over here have opposite signs already. So it will be easier to eliminate than to multiply, okay? So over here, your equation was 1 was 3x plus y 11, and this was 3x minus 4y minus 5, right? So I'll just multiply equation 1 with 4 and equation 2 with 1, and then after that I'll write this, that eliminate 2 from 1. So which will be 1 is now 12x plus 4y 44, and then this one is going to be 3x minus 4y equals to minus 5. I mean, I do not need to separately eliminate it because 4y will automatically cancel each other out as they have opposite charges or opposite signs already. Now eventually 4y get cancels out. 17 plus, so 12 plus 3 turns out to be 15x, and 44 minus 5 turns out to be 39. So x is now 39 over 15, which is 2.6. Now using this x, I can easily calculate the value for y. So I'll just write substitute x into equation 1, which was y 11 minus 3x. So y 11 3 2.6, that will be 3.2. Okay, that is the value for your y as 3.2. And now if I just add all the lengths in terms of x and y, and then at the final stage I just have to give me the value for, like, input the values for my x and y into that final summation, and that will give you the total perimeter over here. So for that total length, now over here I can clearly understand that for perimeter it will be AB plus BC plus CD plus AD, right? For AB we had 6x plus 2y minus 10. Then again we had 3x plus y plus 1. Then again 5x plus 5y minus 10, and 2x plus 9 minus 14 plus 9 minus 14. Okay. Now over here for x we have 6 plus 3 plus 5 plus 2. So 6, 3, 5, 2. That will be 16x. And then again for y we have 2 plus 1 plus 5 plus 9, that is plus 20y. And for numbers over here, we have minus 10 plus 1, minus 9, minus 40. So you have minus 32 number, okay, not with x and y, associated with x and y. So I'll just take this and then again move it to the very bottom. And now finally, I'll just input the values for x and y into this equation. So we have 16 multiplied with 2.6 plus 20 multiplied with 3.2 and minus 32. So we have 16, 2.6 plus 20, 3.2 minus 32. 16, 2.6, 23.2 minus 32. That is going to be, 1 minute. Wait, I think I made a mistake. 1 minute. Plus 2 plus 1 plus 5 plus 9, right? So 2159. Sorry, this one turns out to be 17, not 20. Then you get the final answer as 64. The total perimeter for this case turns out to be 64. Okay. So if I zoom out, this was not entirely a trapezium question, like, I mean a mensuration question. This was a mixture of mensuration and simultaneous equation algebra, right? But this is how it will be done. I think this is clear for everyone. I think this is it for the entire mensuration portion. We're now going to move on to trigonometry. For the next portion, we're going to start with trigonometry. Oh no, not trigonometry yet. I think after this question, we're going to start with trigonometry. So let's start with this one again. Again, we have a solid right prism of A, B, C, D, E, F, G, H, and the base of the prism A, B, C, D is a rectangle and is horizontal, and trapezium BCHG is a cross section of the prism. Okay, BCHG is a cross section, and they have provided you with lengths also that AB, sorry, 1 minute, AB is 4, BC is 3, and then CH is 2.4, and GB is 1.5, and GBC over here, they have provided you with the length, with the angles that GBC, then B, 1 minute, BCH, then AB, ABG, this portion over here is also going to be 90 degrees, and DCH, this portion is also going to be a 90 degree. We need to calculate the volume over here. I can understand that in this portion, the cross-sectional area is this trapezium and height is 4, right? These are your parallel lengths, and height is 3. So for volume in this portion, we can easily calculate that. That is half multiplied with 1.5 plus 2.4 multiplied with 4, and then half into AB plus sine, sorry, half into A plus B into height multiplied with your height, right? Or the length of the of this circular of this prism, right? A solid right prism, right? 0.5 multiplied with 1.5 plus 2.4, 1.5 plus 2.4 with 4 and 4. So you're going to get the total volume as 31.2 centimeter cube. And then again, calculate the angle of depression in degrees to one decimal place of E from G. Okay, so of G from E. Okay, of G from E. Now in this part, actually, GB and ED are not exactly on the same level. You know, if I just try to make a view from this angle, this is how they actually look. On the ground, we have BD, which is basically the diagonal of this rectangle ABCD, and vertically above we have this GB, and on this side we also have this ED. Right, this is how entire thing looks like, and they want to find out the angle of depression from E to G. That means the angle should be over here. Always remember, angle of depression indicates that by how many degrees you have to lower your angle, right? So this is actually the angle of depression. To calculate that, we need to find out the values for this height, which I can clearly understand that if this is G, and this is B. The height of this GB was 1.5, and ED and EC both are of 2.4 centimeter. Okay, so ED is the total length is 2.4 centimeter, and this portion is again 1.5. That means this portion can be easily calculated by subtracting 1.5 from 2.4, right? So we will do that, but now over here for the time being I'll just write it down as 2.4 centimeters. Okay, now again I can easily calculate the height, but over here BD has to be calculated because this length has to be known, otherwise we cannot easily calculate the value for your angle of depression. So for that angle of depression, now for BD we have to focus on ABCD and find out the diagonal BD. Okay, that is easy. Even I already know the value, that is going to be 5, because the two dimensions are 4 and 3. So ABCD, this is the rectangle. This is A, this is AB, then CD, and we need to calculate the length for this BD. Okay. Now for this BD, AB is 4, and sorry, the lengths are actually different. This is AB and CD. Right, this BD we have to calculate. I can clearly understand if this is 4, this is 3. In that case, BD is going to be 4 square plus 3 square, everything under a root, and that will give you 5 centimeters, right? So let's just move this to the very bottom. Okay, now this portion is 5 centimeter. After this part, let's now calculate angles from this entire diagram. Now over here I can clearly understand height in this situation is going to be, or EX, right? Over here EX is going to be 2.4 minus 1.5, which is now going to be 2.4 minus 1.5 is 0.9. Was this in meter or centimeter? Meter. So this is 0.9 meter. Okay, and then again if this is 0.9 and the base over here AX or GX is also going to be 5 meter, right? This is 5 and this is 0.9, and this is obviously 90 degree. With this part I can easily calculate this angle, or you can also consider it as this portion, that by creating a imaginary line over here you can consider that as Y. Whatever the length for EX was, that will be the length for YG, and whatever the length for GX was, that will be the length for EG, right? Using that you can easily calculate this angle of depression directly. This is your angle of depression. On opposite you have this 0.9, on adjacent you have this 5. This is 5 and this is 0.9. So you can easily use tan to find out the angle of depression. So theta now turns out to be tan inverse. On opposite you have 0.9 and adjacent you have 5. So opposite over adjacent. So now you can write tan inverse 0.9 divided by 5. So opposite over adjacent, that is approximately 10.2 degree. So your angle of depression is now 10.2 degrees. Okay, now this is your working for part A. Okay, I hope this part A was clear. No, I think, sorry, this was part B actually, sorry. This was part B for angle of depression. Now after this, they are saying that calculate the length in meters to 3 significant figures for AH. Let's go back to your diagram, and AH is again in between the two diagonals, right? You can clearly see For AH, you have to first find out AC and then use Pythagoras to calculate the length for AH. So for AC now, and this is how AC is, and AH is over here. And then again CH is entirely horizontal. So CEC is entirely vertical, so that will be not a problem for us. Now then again, previously we calculated the diagonal for the ABC triangle already, which was BD, right? Now for one triangle or for one rectangle, the diagonal is going to be same. Doesn't matter if you're going to measure BD or AC. So if you count out, if you scroll back, then BD is 5 meters. So the diagonal for this base BD, right? Or diagonal for this base AC is also going to be 5. So for this part C now, sorry, for part C now, I have to first draw the diagram ACH. Now I have to first mention this, that AC and BD were both equal because they were both the diagonals of the same rectangle, base rectangle ABCD. And now I have all the values. This is 5 and CH was already given in your question. I think that was given as 2.4. Okay, so this is 2.4 meter. And now I can use Pythagoras theorem to easily calculate the value for AH. So for AH, this is going to be 5 square plus 2.4 whole square, everything under our root. 5 square, 2.4 square, which is 5.55. Okay. Calculate the length in 3 significant figures, right? So I'll keep my answer to 3SF. 5.55 is my final answer for H. And for part D, before we start with D, now it says that P lies on GH such that GP is 2/3 of GH, and there's also another point Q that lies on BC, that is 2/3 of BC, like BQ is 2/3 of BC. So we need to find out the angle in degrees to one decimal place for APQ. Okay. Now if I remember, like remove these red lines, GH, right, on GH and then again on BC. For example, around this point, it was at 2/3, right? 2/3 means around this point, your point P will be, and then again at this position, your point Q will be. So if you have to find out the angle, you have to consider this, that AP is not going to be like, no, horizontal. This is going to be a slant length, but AQ is going to be horizontal because A and Q, they're both on the horizontal ground, and PQ is going to be entirely vertical, right? Now for this case, let's just find out the length for GH, and then again using that, let's find out the length for 2/3 of GH, which is going to be GP. Okay. Problem is for GH now, we cannot find out that because that was the slant length of the trapezium. This is how the trapezium was. Now we have to find out the length for GH. So for that, I have to create a triangle, like rectangle, make this a rectangle out of the trapezium. And this is G, this is B, C, and this was H. But I consider this point as Z again over here. That means if this is 1.5, this will be 1.5, and this portion is 0.9, and both of them will create to produce that 2.4, right? And then again, if BC was given as what? I don't remember, 1 minute, as 3 meters, okay? That means if this is 3 meters, and then again this will be 3 meters, obviously this is 90 degree, I can easily calculate GH using Pythagoras theorem now. So GH is going to be 3 square plus 0.9 square, everything under a root, right? So using this, I can calculate, this is 3 square plus 0.9 square, which is going to be 3.13. So that is your total length for GH, but GP was 2/3 for GH. So now I can get GP as 2/3 of this 3.13. So whatever you got from your calculator, you just have to multiply this fraction with that calculated value. 2 over 3 is going to give you 2.088. Okay, so GP is 2.088. Similarly, I already know the value for BC as 3. So BQ is going to be 2/3 of BC. So 2/3 multiplied of 3 will give you only 2. So BQ is a solid number of only 2 and BC is in decimals of 2.088. Then again, if I want to draw a side view of the triangle APQ, right, a side view of the triangle APQ will look like this, because AP was a vertical line and so AP was a horizontal ground, line on a horizontal ground, and then PQ was on the vertical plane. So this is APQ. I already know the length for, wait 1 minute. I only know the length for BC and BQ, right? But I do not have any length for AP and AQ. Then I have to calculate that also. Okay. AQ I can calculate using this AB and BC. Sorry, BQ. I can easily calculate that. But for AP now, hmm, using this base over here, I can easily calculate AQ. But for yeah, using the trapezium also I can calculate the length for PQ, but I cannot calculate the length for AQ actually, or AP. Okay, there's no point of, or there's no possibility of calculating the length for AP, but there are possibilities of calculating the length for AQ and PQ. So using those length, I can calculate the value for your angle APQ. Okay, so before we move on to your calculation of the angle, we still have more works to do. We are now trying to find out the length for AP. Okay, sorry, for AQ. For AQ, they were on the horizontal ground in this format, where this is A, this is B, and this is Q. Where AB is already given, we already know the length for AB was 4 and BQ is now 2. So I can easily find out AQ, that is going to be 4 square plus 2 square, everything under a root, which is now 4 square, 2 square, and this is 2 root 5. And then again, if you see the face or trapezium that this G, P, B, Q creates, right now this is G, this is P, this is B, and this is Q. Right now I have all the sides over here. For example, also there's one point of this GP was already given 2.088. This GB is already known 1.5. If this is 1.5, that means I'm going to consider this as point M now. This is also 1.5, right? And BQ was also given as 2. If this is 2 and like if GM is 2, I can easily calculate the length for PM now also. So PM can be calculated using this Pythagoras theorem again. So PM turns out to be, if I draw a very mini triangle again over here, this is PMG, where GM is 2, GP is 2.088, and this is 90 degree. So this is going to be 0.288 square minus 2 square, everything under a root. So you get 0.5997, you can approximately write 0.6. If this is 0.6, in that case, PQ turns out to be 0.6 plus 1.5. So that is 0.6 plus 1.5, which is 2.1. So now you have all the lengths, all the possible lengths that you have to calculate. So then from this triangle, we already know AQ was 2 root 5. This is 2 root 5 and PQ is 2.1, right? And we're trying to calculate this angle. So we have to use tan inverse opposite over adjacent. So angle APQ turns out to be tan inverse. On opposite we have 2 root 5. On adjacent we have 2.1. Which is now 64.8 degrees, or we can just write 64 point, is it supposed to be in whole numbers? 1 minute. No, it's supposed to be in one decimal place. So we can write 64.8 degrees. This was the entire working for your part D. Okay, this is your final answer for part D, and the answer was 64.8 degrees. Okay, so we are done with all the mensuration maths for the recent question paper. I hope working through this was quite clear for all of you. So we will now move on to trigonometry. This is your next section for this entire PDF revision video. Question is from Jan 2020, paper 2 and question 9. So this one says that figure 3 shows 3 points A, B, C on a horizontal ground. Now this A, B, C, these three are on a horizontal ground, and a vertical mast BT is of height 30 meters is at point B. Now BT, this is on vertical ground. That means obviously this will be perpendicular to C. This will be perpendicular to A as well. And the angle of elevation of T from A. Always remember, from is the indication that your angle should start from this point, right? You should start from A then, because the word from was in front of A. That means we are going to actually measure the angle from A till it meets the line for T, right? This is of T from A is 32 and of T from C is 25. And also the bearing of A from B is the bearing of the bearing of A from B is 195 and bearing of C from B is this much. Calculate the bearing in degrees to the nearest degree of C from A. So let's first create a triangle. Now these will create angle of elevations. Angle of elevations of of T from A was 32. That means over here this particular angle was 32. This is 32 degree, and this part was I think 25, right? Yeah, of T from C is 25 degree. And then again, if you want to find out that of the bearing of A from B, of A from B and of C from B, this one of A from B, over here of A from B, I will have to connect this A and C together. Now it creates a complete a complete triangle. And then again, it was stated that the bearing of the bearing of A from B, right? So from this part, if I'm going to consider that maybe this is like the north, okay, this is like the north of B in that case, of A from B. That means if you start, calculating the bearing, this is turned out to be 195, and then again the bearing of of C from B. That means again from the north plane over here, again from the north side of point B, we will start rotating. and it will continue until it reaches point C, right? This is how they have given you the informations for off C from B, and this was 280 degree, and they want you to find out the bearing of C from A. That means from A they want to find out the bearing, that what was the entire angle, right, over here. For maybe this is like this angle they want to find out. Okay. So at first what I have to do is that I will draw the base triangle ABC in a separate diagram to clearly justify exactly how we are supposed to calculate the bearing and what we are actually trying to understand, because from this diagram it's quite very messed up, so we cannot understand clearly from this diagram. So I would suggest let's just draw a diagram separately for the base only. This is how the base was for ABC. This is approximately how the base was, and then again these are the north poles, like north side for all the 3 points. Okay, this is exactly the north of B. Now the bearings that were provided to you, that this one was 195 and this point is B over here, and then again the bearing of B from C. This is of B from C, which was given as 280. So from this part, I can clearly understand. I can easily find out the angle B over here. That is basically going to be the subtraction for the red angle or from the black angle, right? Like I just have to subtract 195 from 280 over here. Like basically, I have to subtract that bearing of A from B with bearing of C from B in order to get this value for theta over here. So I can easily calculate that. And then again, these were points C and A, right? This was point A. If I can find out the length for AB and BC from those elevation concepts, okay, using the elevation and then vertical mass BT, I can easily find out the length for AB and BC. Using that, then again, I can find out the length for over here, the point A I can calculate. And for this part in this particular maths, one thing is that if I extend this vertical planes, right? If I extend this north poles over here, I can understand that obviously over here, whatever the value that I can calculate for this entire angle A, right? I can just from I can subtract that angle from 360 to get this outer values, which will actually be required for your calculations of C from A. And then again, the problem is that if I want to find out this much angle, exactly what was the bearing over here, because for bearing of C from A, your angle must start from north, right? So if you want to start from north, this one portion that we cannot calculate, this one portion we can calculate that from this section over here, right? And we know this section is what, 15 degree, because this total was 195, this is 180, and this is extra 15 degree, right? So if this is 15 degree, this is 15 degree, I just have to calculate this angle to finally get out to the outer skirts for your of C from A angle. Okay, I hope the concept is clear. So let's start with the working. Now for this theta over here, theta will be basically bearing of C from A. Sorry, I think I made a mistake. This is of C from B, and then again I'm subtracting this with of A from C, of A from B. Okay, and this was 280 minus 195, which gave you 85 degrees. Okay, so you got the value for your angle as 85 degrees. And then again, if I use the elevation concepts to find out the length for BC and AC, we can also find out that. Again, from this diagram, you can clearly see that this BT was perpendicular with AB, right? So we can just draw a very clear diagram over here. Now this was B, T, A, and the base was, I do not know the length. I want to find out that, right? This was 32 degree, and this was 30 meters, and this is obviously 90 degree because BT was horizontal, BT was vertical, and AB was horizontal, and we can clearly understand we have to use tan. So AB in that case would be opposite divided by the angle, right? So it's going to be 30 divided by tan 32. That will give you the value length over here, which is approximately 48.01. And then I'll copy the same thing and start doing this for the triangle CBT this time. And now the angle was 25 degree, not 32 anymore. And for this section again, I can calculate the base CB, which is going to be similarly 30 divided by tan 25 degree, which is now creating almost 64.3 meters. Okay. And then again, if I draw that base triangle ABC again, for the base triangle ABC, now I have corresponding lengths. This is ACB. This is 64.3. The angle I calculated, and I got the 85 degrees over here. And this one was 48.01, and I want to find out this angle, right? This angle over here, angle A. So I can easily find out angle A using the, wait. Yeah, I could find out angle A, but problem is I could still not use sine rule over here, right? So I actually have to find out the length for AC with this cosine rule, and then use sine rule to find out the value for angle A. So let's just first find out AC, which is going to be like 64.3 whole square plus 48.01 whole square minus 2, 64.3, 48.01, and then you just have to multiply again this with cos 85 degree, and everything has to be under a root. So you get 76.8 centimeters as your length for AC, or meters actually. This is your length for AC, and now you can use the length for your AC, angle B, and CB to find out the length for angle A, or a value for your angle A. Now sine angle A is going to be divided with 64.3, and then again sine 85 degree is going to be divided with that 76.8. Finally, angle A would be sine inverse 64.3 multiplied with sine 85 degree divided by 76.8. Okay, now if we just directly calculate the value, sine inverse 64.3 with sine 85 divided by 76.8. You're going to get 56.5 as your theta, 56.5 degrees, right? Now if you go back to your triangle again, now you can easily get the reflex part of your bearing, right? The reflex part of your bearing is going to be like 360 minus 56.5, and I already know this portion is going to be 15, right? Because this is exactly a concept for your interior angles. These two knots were parallel to each other. That means over here, this is your not interior. This is alternate angle, right? If this angle is 15, in that case, this angle over here would also be 15. So according to that basis, now the bearing of final answer over here is going to be that. Let me just explain that portion again. This was 1 minute. right? This is how the lines were there for the corners for A and B, right? This point over here was B and it was in total creating 195. So how would I break down that 195? This is 180 and this is extra 15 degrees. That means this portion over here is going to be equal to that 15 degree. So angle A is also 15 degrees, and now using this angle A as 15 degrees and this reflex of that bearing, so the total bearing of C from A turns out to be 15 degrees will be added with the leftover of 56.5. So that leftover of 56.5 will be 360 minus 56.5. So which is going to be 15 plus 360 minus 56.5, and that turns out to be 318.5. Okay. Now I do not know if they were asking for nearest value. Yeah, they were asking for nearest degree. In that case, the final answer would have been 319 degree, not 318.5, right? This is your final answer. Okay, I hope this part was clear for all of you. I mean, I would actually agree with you that this is extremely difficult to understand and also to comprehend inside an exam. But this was again from a very old paper, so I hope this kind of questions never come in your exams for this May 24 session. So this is it for trigonometry. And like first question of trigonometry, let's move on. This is also kind of like the trigonometry and also kind of related to ranges. Okay, now this question is about question. This is related to trigonometry. Now we can see there are two figures, right? On the left you have a rectangle ABCD with dimensions 2x plus 3, 4x minus 7, 8, and on the right you have a triangle with angle theta. And again you can understand that this triangle is actually an isosceles triangle, right? Because these lines over here on this line EG and GF is indicating that these two lines are of equal length. And then again, if this is an isosceles triangle, that means if your angle E is theta degrees, that means your angle F would also be theta degrees. They will have the same angle, right? That is the base of your isosceles triangle concept. Now for figure 4 shows a rectangle ABCD and isosceles triangle EFG where EG and FG are of equal length, and they have given you these dimensions over here, and this theta where it was also stated that tan theta is equals to half. So from this expression you can actually calculate the value for your theta also. Now use the perimeter of the rectangle is P and the area of the triangle is T. You have to, like, it is given that P is greater than and equals to T. So find the range of possible values for X, show your working clearly. I mean, we just have to find out the perimeter of this rectangle, and then again we have to find out the area for this triangle. So for this rectangle's perimeter, I can understand I just have to add this ABDC and BCAD together. So for P, perimeter of the rectangle, this is what? Just P, which is going to be twice length plus twice breadth. So twice length is 2x plus 3. That's 4x plus 6 plus twice breadth. 4x minus 8, that's again 8x minus 16, and which is eventually going to be 4 plus 12 is 12. So 4 plus 8 is 12 and 16 minus 6 is just 10. Right, that is your final answer. That is your case for perimeter. Now using this perimeter we can also find out the value for the area of the triangle. For that area of the triangle, let's first find out the value for theta. Over here, if the tan theta is equals to half, in that case theta is equals to tan inverse half, which is going to be 26.5 degrees, 26.6 degrees actually, right? That is the value for theta, 26.6 degrees. Now using this value for theta, 26.6 degrees, you can clearly understand I can easily calculate the value for this angle. But wait 1 minute. in order to find out the area, I can easily calculate, and I over here I have to use the concept that half AB sine theta can be used, but then again the two other lengths for this triangle are not given. So which means I only have one theta, one side over here, and then I can easily calculate this angle G over here using the no, I can, yeah, using this total angle theorem, and then using that, yeah, using that and then cosine, but I still have X over here. 1 minute. Hmm. If I could calculate the height over here, like the perpendicular height, in that case also it will do the work, but this is still 90, this is 2x plus 1 in that case, this one is 26.6, but this still doesn't give you anything about the height. Yeah, there is no other way actually. We have to find out the value for theta and then again use cosine sine rule to actually get the area for this triangle T. Now for this case again, I'll just do the working from this part for the triangle over here, EFG. For the top you had G, this is E and this is F, right? EFG, right? Now this angle we calculated turned out to be 26.6 degrees. This one is also 26.6 degrees because it was an isosceles triangle. So which means angle F and angle E both are basically tan inverse half, and which is going to be your value for, yeah, tan inverse half, which is going to be value for 26.6 degrees. Another thing you can understand that if the value of your tan theta was given in this format, the tan theta was given 1 over 2, right? That means it has a ratio of half. So how do you actually get tan? If I can again create a straight line over here, tan is basically opposite over adjacent, right? So in that case, this is 90 degree. There's actually a very easy way. For example, for this vertical height, if I'm going to consider that as point maybe M. Okay. Now, if you just take this EGM separately, if you just draw this thing separately, we can clearly understand that if EF was 4x plus 2, half of that will be EM, right? So this EM then turns out to be 2x plus 1. Half of that EF. EF was 4x plus 2, half of that is 2x plus 1. And now you have EMG. And then again for tan theta, you got tan theta was opposite over adjacent. In that case, 1:2 is a corresponding ratio over here. So using this part again, I'll consider 1 represents h and this 2 represents your 2x plus 1 length. Right. Now using this part, I can easily calculate an expression for h over here. For the expression for h, this is going to be opposite over adjacent, that is 1h divided by 2 multiplied with 2x plus 1 is equals to tan theta. So therefore for tan theta now, in order to get an expression for h, I can easily rearrange it and send and write it like this, that tan theta in that case would be like half of this 2x plus 1. Wait 1 minute. Half of this 2x plus 1, sorry. This is an expression for h and in terms of 2x plus 1. Yes, and that is also equivalent to, wait 1 minute. This is also equivalent to half. Now, as we can see, tan theta is equivalent to two of the equations, right? It's in one equation it is equivalent to half, and in another equation it is equivalent to h over 2x plus 1. This is your first equation for tan theta that was given in your question, and this is your second equation. Wait 1 minute, let me just write this in a much more defined way. Right, this is your second expression for tan theta. Now as I have two expressions for tan theta, I can just easily substitute 1 into 2, and that will make your equation look like h over 2x plus 1 equivalent to half. And now I have an expression for height over here, which was the GM. Height is now half 2x plus 1, right? Now for the triangle, I have the height, I have the base, right? Base was this total EF, 4x plus 2. Height is this half, 2x plus 1. So for this triangle's area T, we can write half base into height. Base was, as I've said, that it is 4x plus 2. So this is 4x plus 2, and height was itself 1 by 2, 2x plus 1. I can simplify it further. For example, I'll keep the half in front as it is, and I'll try to take 2 as a common factor from this 4x plus 2. So if you take 2 as a common factor, you get 2x plus 1 multiplied with half and then 2x plus 1. So eventually this half and 2 gets cancelled out, and now you're left out with what? Half. You have these 2x squares multiplied to each other. So eventually it will be 2x plus 1 whole square, right? So that is your total area. Expressions for the total area of your triangle. It was already given to you and one inequality regarding this, that perimeter is greater than equals to triangle's area. So using that inequality again, perimeter is greater than equals to the triangle's area. Perimeter, now we calculated that in this first page, 12x minus 10. From there also I can take 2 common. So I'll just write this as first align, the 12x minus 10 greater than equals to half, and 2x plus 1 whole square. So if I take 2 as a common factor from the left hand side again, I'm going to get 2. This is going to be make 6x minus 5 and half. And then again, you on the right hand side, now I can break down that square and write it as the formula for a square plus 2ab plus b square, which is going to be 4x square plus 4x plus 1. And then again, if you take this 2 to the right hand side, or if you take this half to the left hand side, it will become 4, 6x minus 5, then 4x square plus 4x plus 1. Then again multiply this 4 with the left hand side, whatever you have on the brackets on the left hand side. So you're going to get 24x minus 20, 4x square plus 4x plus 1. From this part you can just carry out all the x's to the one hand side, and it will look like 4x square plus 4x minus 20x plus 1 plus 20, 0. And now you have 4x square minus 16x plus 21, 0, right? Now if I zoom out, using this I can easily do middle term over here. For that middle term, I'm going to use my calculator and find out the value for a 2x's that I'm going to get out of this. Also another thing, for all the cases I'm not supposed to use equals to. I was supposed to use greater than equals to, right? Greater than equals to. For this part also greater than equals to. This time it will be less than equals to, because over here on this step I actually flipped the equations, because you can see this 4x square was previously on the right hand side, and now in the last second line it is on the left hand side. So basically I flipped it. For that flipping, the greater than equals to turned out to be less than equals to over here. So from this part now I can easily do the middle term. So it will give you 4 minus 1621. Wait, it doesn't give you any solution. 1 minute. This was positive 4, and you have, wait, sorry, this was actually 24, not 20. So this one turns out to be eventually 20. This was 24x, so this is not 20x. Now using this 4 minus 20 plus 21, that turns out to give you 7 by 2, 3.5, and the other one would be 3 over 2, 1.5. So if you do the middle term over here, which is going to be either 7 by 2, right? That's 14 and 7, right? So you're going to get 4x square minus 14x minus 7x plus 21. That gives you 3, but wait 1 minute. 7 by 2 into 4, that's 14, and 3 over 2 into 2, 4 is 6. Right, 14 plus 6 is 20. Okay, this is supposed to be 6 then. This is 6x. That is less than equals to 0. And now using this again, what do you have? 4x square. I can take 2 as a common factor for 4 and 14. So 2x, that is going to be 2x minus 7. And then again minus 3. That's going to be 2x minus 7 less than equals to 0. Which is now going to be 2x minus 3. And then 2x minus 7 less than equals to 0. Which is now going to be 2x minus 3 equals to 0. The critical point turns out to be 3 by 2. And 2x minus 7 equals to 0. X equals to 7 over 2. Right? These are the critical points. Now then again, we are only trying to find out what? The lower than 0 portions. Right? These are your lower than 0 portions. If you guys remember, this is how I actually find out that if you're working for the positive section or for the negative section, you're actually trying to find out this portion of the graph. This was your 7 over 2 and this point is 3 over 2. You can understand the region is greater than 3 over 2 and less than 7 over 2. In this situation, the final range turns out to be x less than 7 over 2 and greater than 3 over 2. So that is your possible range for your values for x. I hope this was clear for all of you. This is the entire working that you will need to calculate the processes for this question. Other than that, nothing else will be required. Right, this is it. We found out the perimeter, then we found out the triangle's area, and then we compared the two areas and perimeters together to finally get the value for your x. This was not entirely related to trigonometry. This was slightly related to your concepts about mensuration also, right? But quite related to angles, so that's why I had to input this over here. And that was it for this question 11 of June 22 2PR. We'll now move on to the next question. This is for June 23 paper 2. And this is question 4. Okay, over here it says that, wait, again, this is not entirely from trigonometry, sorry. This is a little bit from geometry. Okay, but this is not going to be that much tough, so we can easily solve this. Now over here, we can see that the interior angle of a regular polygon is 172. We need to find out the number of sides of this polygon. We can easily calculate that using that n minus 2 into 180 degree divided by n, right? Over here, they are giving you the interior angle for, the interior angle is 172 for a certain type of polygon with n number of sides. So for part A, interior angle is 172 degrees. The formula for interior angle is n minus 2, 180 degrees divided by n equals to 172 degrees. And now I just have to make n the subject of this formula. So 180 n minus 360, 172 n, which is now going to be 180 n minus 172 n, then 360, which is now 8n, 360, so n is 360 over 8, and that turns out to be 45. So this was a 172 degree interior angle was for a polygon with 45 sides. Okay, that is your answer for part A. And after this, it is stated that the length of each side of the regular polygon is 5.2 centimeters to two significant figures. This is about rounding up again. And they're also giving you this, that calculate to centimeters square to three significant figures, the upper bound of the area of the polygon. Okay, now over here, as they were creating like what? 45 sides, right? 45 sides means that you can actually fit in 45 triangles inside that polygon. Because if you think about it like this way, right, as I was saying, so if you could think about it in this way, that for example, if you have a six-sided hexagon, right? For a six-sided hexagon, you can actually fit in six regular triangles, six regular equal triangles inside that hexagon. So depending on the number of sides, you can actually fit on fit down the number of triangles inside that structure, inside that polygon. Now it is not possible for me to draw a structure with 45 sides, but it is possible for me to understand that inside that 45 sided polygon I can fit in equally 45 equal triangles inside that polygon. That means now over here, for this 45 equal triangles inside that polygon, I can find out the area for one triangle and then multiply that with 45. And also over here, it was stated that the length of each side of the regular polygon was 5.2. So this is how it will look like. Like for example, the one particular triangle, if I'm talking about, right, this one, and this is on the outer part, by the way, and these were on the inner parts of that polygon. The outer parts of the polygon had a length of, like, I'll just name this randomly A, B, C, and this is going to be like 5.2 centimeter. Corrected two significant figures. We also have to find out the upper bound for this 5.2, and after this again they also want to find out that what was the area over here for each triangle they would create. Okay, 1 minute. Yeah, for area again, I can understand that if for a hexagon, the sum of the angle, the center is 360, that means for every angle, I just have to multiply 360 divided by 6 to get to the angle at the center for one triangle. Now, as I've already understood that for 45-sided polygon, there will be 45 equally sized triangles fitted inside that polygon. That means now if I want to find out this angle at the center for 45-sided polygons, angle 45-sided polygon, this is now going to be what? 360 degrees divided by 45, which is going to be 8 degrees now. 360, yeah, 360 divided by 45 gives you 8 degrees. That means for every angle, this portion of angle was 8 degree. So if that is 8 degree, I can easily. Okay, now if this angle at the center is 8 degrees, then I can also calculate the angle at the point A and B at the corners. And another thing I already know, that the triangles that I'm going to fit inside this polygon of 45 sides are all going to be an isosceles triangle. That means over here, if I can, let's just first find out the angles for A and B. For this angle A and angle B, I already know they are equal. So in that case, I'm considering them as theta. So using the total sum of a triangle, that is theta plus 8 equals to 180 degrees. In that case, theta turns out to be 180 minus 8 divided by 2, which is 86 degrees. So for this, now every angle at A and D, A and C. So not B, made a mistake. This is C I'm talking about. And this is the angle B, which I calculated as 8 degrees. Okay, now with this theta or angle A and C is 86 degrees. Using this, I can also find out the height over here. So in this case, the height is, this is where the height would be. Okay, yeah, whatever it is, like this is the height over here, right? The black line over here is the height now. And using this height concept, right, I can consider that as h. Now I'm then again consider this is the midpoint of AC, which can be considered as m, and that will be half of 5.2, right? And this angle is 86. So I'll just again draw a very small triangle of this ABM. So this is A, this is B, this is M. AM is now going to be 5.2 divided by 2, which is 2.6. This is now 2.6. Height is unknown. And height is unknown. And this angle is already known to me, that is 86 degrees. Using this 86, I can calculate the value for height. So height here turns out to be opposite over adjacent. So tan 86. So in that case, this is going to be 2.6 multiplied with tan 86 degrees, right, which is 2.6 multiplied with tan 86. That gives you the length, wait, 2.6, yeah, that gives you the height over here, 2.6, 1 minute, 2.6 with tan 86. Now that is 37.2 centimeters. Now the area for one triangle is going to be half into base into height. For the total hexagon, or for the total polygon with 45 sides, is going to be one triangle multiplied with 45. But then again, I forgot what I was trying to find out. Yes, I want to find out the upper bound. Okay, 1 minute. I had to find out the upper bound. For that upper bound, this will be a little bit changed because I would have to use the upper bound of 5.2. Okay, so for that, we will have to do a little bit changing over here. That 5.2 centimeters was correct to 2 SF. Okay, 2 significant indicates that a certain value has to be added and multiplied with this 5.2. 2 significant means 0.1 divided by 2, which is going to be 0.05. That means the upper bound value is going to be 5.2 plus 0.05, which is 5.25, and the lower bound value of this 5.2 is going to be 5.2 minus 0.05, that is 5.15. Now using these values, I can understand 5.25 divided by 2 would give you, this one actually turns out to be 2.625. So for this part, this will have a little bit change, right? Because now it has two more significant values, which is going to be tan 86 degrees. And you're going to get the final answer is 37.5, not 37.2. Okay, that is your final height over here. Now using this height, I can calculate the area and then multiply that with 45. So the total area over here is going to be 45 multiplied with half. Base is 5.25. We need to use the higher bound value for base because maybe we were trying to find out the higher value for this area. Okay, so this is, we are trying to find out the upper bound value for area. So for upper bound value for area, we have to use the upper bound value for this length, 5.2. So this is going to be this multiplied with 37.5. So finally, 45, 0.5, 5.25 and 37.5. That will give you 4429.6875, so which is approximately 4430, right? This much meter square, I think, or centimeter square. Now we were supposed to give our answer in 3 significant figures, so that's why I'm giving my answer as 3 significant figure over here. So this is it for the working. I hope this was clear for all of you. This was the entire working for part B. This was the working for part B. Okay, this is it then. Let's move on to the next question. Okay, now this file is from June 23 to PR. So let's start. We have a triangle over here. The figure 1 shows a framework for wooden beams with ADC is a straight line. This one is a straight line, and there are lengths given as AB as 8, BC is 3.5, and BD is 2.5. And it is also stated that this angle ABD is 90 degrees. That means this portion of the angle CBD would also be 90 degree over here, right? So we need to calculate, giving your answer to the nearest meter, the length for AC. So in order to calculate the length for AC, I can easily calculate that in 2 parts. I can use Pythagoras separately to calculate the length for AD, and then again I can use Pythagoras separately to calculate the length for DC. Right, and then add the 2 lengths together to get the final length for AC. So for part A1, I will divide the entire triangle into 2 sections, ABD and CBD. This is how ABD looks like. This was A, B, D, and it was also stated this was 90 degree. I mean, over here, if you think about a straight line, right, sum of a straight line is 180 degree. If one portion is 90, the other portion would be 90. That means this portion is 8 meter. This was 2.5 meter. Now you need to find out the length for AC. Okay, this is not C, this was supposed to be AD, sorry. Now, for AD, I can easily calculate that. It is going to be 8 square minus 2.5 whole square, everything under a root. So for this part again, if you start calculating it, 1 minute, 8 square minus 2.5 5 square. So you are going to get 7.6 approximately. You can write 7.5993 also, but eventually it will give you 7.6 meter. And then you have this triangle. The other portion of the triangle was a BDC, right? This is how BDC would look like. And for this BDC, this is BDC. BC was 3 meters maybe, so 3.5. And we know according to our sum of a straight line, this angle over here would be 90 degrees over here again, and BD is again 2.5, right? So we can again calculate CD or DC, that is going to be 3.5 whole square minus 2.5 whole square, everything under a root, which is going to give you root 6. Finally, for the total length for AC, I'm going to get AD plus DC, which is 7.6 plus root 6, and that is 7.6 root 6, which is 10.05. Okay. That is your length for AC, but we're supposed to keep our length for AC to the nearest meter, right? I think, wait 1 minute. Yes, we are supposed to keep our length for AC to the nearest meter. So in that case, this turns out to be exactly 10 meter, right? 10.05 to the nearest meter will be 10. Now this was the entire working for part A1. After this, we are moving on to part 2, where they want to find out the angle to one decimal place for BAD. BAD is this angle. I can easily calculate that using opposite and hypotenuse, using sine over here, right? So for this, 1 minute. For part B now, I can easily calculate this angle, which is opposite is 2.5, hypotenuse is 8. So I can use sine theta or sine angle BAD is equals to BD divided by AB, and eventually angle BAD turns out to be sine inverse BD was 2.5 divided by 8. So if you calculate this, then you can easily get the value, which is going to be 18.2, right? This is now 18.2 degrees. Now from this part again, then further it was stated that the fourth beam DE is added to the framework, and the point E lies on AB is such that DE is now perpendicular to AB. We need to calculate the length in 3 significant figures for DE. Okay, now in this diagram, I'm going to connect another point on AB, and it will actually be in this format, that now DE, this is point E by the way, the new point I have introduced on line AB. This is point E, and this DE is now perpendicular to your AB this time. Okay, now they want to find out the length over here. So one thing you can understand is that basically for ABD, okay, you can actually find out the triangle for ABD, even if you use this as a height and this as base. And again, you can find out the triangle area for this triangle ABD, even if you use AB as base and DE as height, right? This eventually gives you the same area, because they are under the same triangle, right? Once you're considering the base as AD and height as BD, and then again for the second scenario, you're considering the DE as height and AB as base. So for this portion, if I can just draw a diagram over here. This was A, B, and D. This point was E, right? A, B, D, E. And there's actually two variations of this triangle. One variation is where we're considering this dark line DE as the height, and this AB 8 meters as the base, And then another variation we have is this for ABD, where BD is 3.5 meters and AD, the length for AD was, I think we calculated that in part A1, that was 7.6 meters. So this is now 7.6 meters. So I can easily use half into base into height and make the two areas equal to each other to get the final length for DE, correct to three significant figures. So I can write that half multiplied with base was 8 multiplied with height, and that will be equals to half multiplied with 7.6 multiplied with 3.5. I can clearly understand this half and half will cancel each other out on both sides of the equation, and now you're left out with 7.6 multiplied with 3.5 divided by 8. So if you calculate this now, 1 minute, 7.6, 3.5 divided by 8, that gives you 3.325 meters. 1 minute. Oh wait, sorry, made a mistake. This was actually 2.5. The length for BD was 2.5. Really sorry. This was 2.5. Okay. Now if you do this calculation again with 2.5, you're going to get 2.375. So at the end, if we were supposed to keep our answer to three significant figure, we have to keep this in 2.38 meters, right? Now again, my answer will not be entirely accurate because the value for this 80 was correct to one decimal places, But if I would want to get the accurate value, in that case, it would be better if I could use the accurate value for 7.6 also, which was actually 5.99, 0.5993. That was the actual value for 7.6, 5.993. So now if I just do recalculation for this, 993, I actually get 2.374. So in that case, 2.374, so 37 meter is your final answer, correct to three significant figures. Okay, that is your working for part B. I hope part B was clear for all of you. This was not that much tricky to understand or even to explain. And that was the end for your question 5 from June 23 to PR. Let's quickly move on to the next question. That is again from Trigonometry, June 23 to PR, question 11. From the same paper, this is question 11 now. Now for this part, for question 11 this time, we have been provided with a triangle, and it shows the triangle ABC has dimensions AB 4 root 3, BC 3 root 5, AC as x, and this angle BAC as 15 degrees. Now, it is also stated that the exact value for cos 15 is this much, and using all these values, you have to show that x is a solution for this equation. X is a solution of the equation this, okay? 1 minute. Okay, let's start with actually trying to calculate that if we can find out the expression for cos theta using these lengths or these values. So which is going to be 3 root 5 is in the opposite place and 4 root 3 is in the adjacent. So cos 15 degrees. So you have x square plus 4 root 3 whole square minus 3 root 5 whole square. I think it was 3 root 5, right? Yeah, 3 root 5 and divided by 2x 4 root 3. Now I already know the value for cos 15 was what? 6 root plus 2 root divided by 4. So this is root 6 plus root 2 divided by 4. And this portion again we can simplify it for x square for 4 root 3 whole square. I'm actually going to get 48. So this is going to give you x square plus 48, and then this 3 root 5 whole square will give you 45. So 48 minus 45 gives you 3. So x square plus 3 divided by 2 multiplied with 4 root 3 gives you 8 root 3. So 8 root 3x is equals to root 6 plus root 2 divided by 4. And then again from this part onward, I can do cross multiplication. For cross multiplication, I can get 4x square plus 12, and this 8 root 3x actually will be multiplied with root 6 plus root 2, which is now going to be 4x square plus 12. This 8 root 3 multiplied with root 6 actually turns out to be 24 root 2x, and this 8 root 3 multiplied with root 2 gives you again 8 root 6. Okay, now this part, if you move on, you can clearly understand that the given equation we have 6 root 2, 2 root 6, and then 3, right? Yeah, I mean, I just have to like take everything to the right hand side now, so to the left hand side. So it is going to be 4x square minus 24 root 2x minus 8 root 6 plus 12, that is equals to 0. And from this part again we can take 4 as a common part. So if I take 4 as a common factor, I will get x square minus 6 root 2x, then minus this is also actually x, there's also actually x over here. This is going to be 2 root 6x plus 3 equals to 0. Okay, let me just take everything to the next page, because writing all of these things in one page is very, it would be very easier for you to understand. Now if you take this common factor to the right hand side, it will be obviously divided with 0, and eventually it will just vanish out from the entire equation. So you're going to get x square minus 6 root 2x minus 2 root 6x plus 3 equals to 0. And finally I can take this x square and minus as a common. So inside the brackets you have 6 root 2 plus 2 root 6 x plus 3 equals to 0. Now this was the equation that we had to show in part 1, and we successfully did that, right? That is the final working for part 11a. After that, we'll move on to the next part, where the equation given in part 1 is in the form of this. Write the equation in part 1 in the form of this, and where k is a constant, and this should be stated in a simplified third. Okay, as we have a square over here, I can clearly understand you have to now over here do completing the square, right? In this section, you have to start with the completing the square function. For part B again, let's start with this. 1 minute. You have x minus k whole square, 12 minus 21 minus plus 12 root 3. Okay. Answer should be in the format of x minus k whole square 21 minus 12 root 3. 1 minute, let me just check again. 21 plus root 3. Okay, now from this point onwards again, we are going to start with the original equation. Okay, this is the format in which your answer should be at. But let's start with the equation we left our maths in part A1 or part A. This is the final equation we stopped our maths in part A. Now for this part, we have x square minus 6 root 2 plus 2 root 6, everything under like with x, and 3 equals to 0. For this part, the value for a is 1, b is minus 6 root 2, sorry, 2 minus 2 root 6, and c is again 3, right? So these are the values for a, b, c, and then again over here, like using these, I can calculate the value for, like in completing the square, I can write it as capital A is now equals to, wait 1 minute. Capital A is obviously always equals to small a, so this is 1. Capital B is always equals to B divided by 2a, which is now going to be minus 6 root 2 minus 2 root 6 divided by 2. I can actually take 2 common from the numerator, and it will be 2 minus 3 root 2 minus root 6 divided by 2, and that will be minus 3 root 2 minus root 6. And finally for capital C, this is going to be C minus b square by 4a. So for c, minus 6 root 2 minus 2 root 6 whole square divided by 4 1. If you do this on your calculator entirely, that is 6 minus 6 root 2 minus 2 root 6 whole square divided by 4. 6 root 2, 2 root 6. And that will give you your answer as 21, 12, 13. This is minus 21 minus 12 root 3. Okay, now I already know whatever the final or whatever the quadratic equation was, I can actually do completing the square and write your answer like this in this format. Let me just highlight this. This is the value for A, this is the value for B, this is the value for C. Okay, in completing the square, what we do is that our equation could be written in this format: ax square plus bx plus c, and we will write this in the format of capital A x plus capital B whole square plus capital C. Over here in this maths, the equation was in the format of x square minus 6 root 2 plus 2 root 6x plus 3, and that will be equivalent to x is 1, x plus, this is going to be the value for b was minus 3 root 2 minus 6. So I can write minus 3, or I should actually write it like this, that x minus 3 root 2 plus root 6, this entire thing under a square, 3 root 2 plus root 6. And then again for part C, now we have the value for us 21 and 12 root 3. Now this is the final completing the square format. Okay. Now finally, if we go back to your question again for the last time, they were saying that write down the equation in part A in this format. Right. I already know the equation is equals to 0. So which means over here, this quadratic equation is actually equals to 0. Now this will be also equals to 0. Okay. Now again, I'll write the value for A, B and C separately to highlight them. For example, over here, or just 1 minute, no, I just rewrite this once again. The value for A was actually, or I should just write this and then highlight it, no problem. 1, x plus minus, and this was 3 root 2 plus root 6 plus minus 21 minus 12 root 3. This is equals to 0. From this part, if I highlight the values for A, B and C, this is the value for A, this is the value for B, and this is the value for C. This is A, B, C, right? A, B, C over here. And now again, there's no point of writing 1 in the front. And this is how it will look like. X minus 3 root 2 plus root 6. Everything under a square. If you just take this C to the right hand side, it will be now in the format of 21 12 root 3, and this is the exact format your question was given. And now we can understand that in the space for k, right, the value for k is now going to be 3 root 2 plus 6. This was the space for k. So finally I can write k is actually equivalent to 3 root 2 plus root 6. That is the value for your k. This is the entire working for your part B. We did the completing the square and gave your answer in the given format as a question. Then again after that, we have this corresponding idea that given that angle ABC is an obtuse angle, obtuse means obviously this is greater than 90 degree. So this angle is obtuse angle, and some parts of B and C to find the exact value for B. Okay, I'm going to give the exact value for B in this format where A, B and C, D are integers, and you have to find out that. Okay, that means you also have to find out some parts, like you have to also use some parts of B and C. Okay. But then again, before before D, because we also have to calculate this one. That is 3 plus 2 root 3 whole square is actually equivalent to 21 plus 12 root 3. Let's show that these two are equal to each other. Okay. Right, show that 3 plus 2 root 3. So we just have to like show this. Okay. So we'll start with 3 plus 2 root 3 whole square. And now which is going to be like 3 square plus 2, 3, 2 root 3 plus 2 root 3 whole square, which is going to be 9. This is 6. 6 multiplied with 2 is 12 root 3. And this one is going to be 4. 3. 4 multiplied with 4 multiplied with 3 is 12. Right, so 12 plus 9 is 12 plus 9 is 21, right? Yeah. This is 21 plus 12 root 3. Obviously, they are equals to each other. Now, using this, I can actually also use this in this portion. Instead of this 21 plus 12 root 3, I can also write this time that 3 plus 2 root 3 whole square is also equivalent to 21 plus 12 root 3. But that's a later part. Let's start with the working first for part C now. For part D now, that was part C. For part D now, it was already stating in the question that the angle ABC was an obtuse, and you have to use your ideas about point B and C to get the exact value for A for C. Okay, this is not going to be a broken value. This is supposed to be an exact value. So if that is an exact value, for example, from part C, okay, from part C, I already proved that this 3 plus 2 root 3 whole square is actually equals to 21 plus 2 root 3, so 12 root 3. 12 root 3. Now for this section again over here, I can write this down as, and then again from part B now, the completing the square format was x minus 3 root 2 plus root 6, everything under a square, and that was equivalent to 21 plus 12 root 3. This time, instead of writing 12 root 3, I can write this portion in this position, right? Because they are both equal. 12 root 21 plus 12 root 3 is actually equals to 3 plus 2 root 3 whole square. So I can write x minus 3 root 2 plus, I can break down root 6 also. Root 6 is going to be root 2 and root 3, right? So let's just keep it over here for the time being, and then if you want to break down, we'll break down in the later workings. This is equivalent, this is entirely under a square, and that is now equivalent to 3 plus 2 root 3, everything under a square. We can clearly understand that both sides of the equation are square. If I just take the square from any side to the other side, they will cancel each other out. So basically over here at this stage, the squares, the powers on top of the numbers on the right and left hand side are going to cancel each other out. And now you're going to be left out with x minus 3 root 2 minus root 6, then 3 plus 2 root 3, and then just take everything over here to the right hand side to get the value for x, right? So that will be x equals to 3 plus 2 root 3 plus root 6, then again plus 3 root 2. That is the final answer. But in your question, they were arranged in a different matter. They were arranged in 3 plus 3 root 2 plus 2 root 3 plus root 6. That is your final answer for x. Okay, we do not need to calculate anything. We would just have to rearrange it and substitute few informations from C to B to get the final value for x in part D. So I think in part B they have also given you one expression over here. 1 minute. Yes, A, B, C and D, right? In that case, the value for A turns out to be 3. The value for B is that also turns out to be 3. C is 2 and D is, sorry, made a mistake maybe, 1 minute. Yeah, C is 2 and D is going to be that 6. So these are the workings for your part D. I hope this was clear for all of you. This entire question from, I think this is June 2023 2 PR. This was from question Yeah, question 11 from June 23 to PR. This was from the trigonometric part. I hope this was clear for all of you. Let's move on to the next section. Next part is probability, and we're starting with the Jan 2020 2PR question 3. For this one, it says that Peter has two boxes of bricks, box A and box B. Each box contains only red bricks, green bricks, and yellow bricks. And in box A, there are 15 bricks, of which in box A they have total 15 bricks, right? And of which 5 are red, 7 are green, and 3 are yellow. And in box B, there are 20 bricks, of which 8 are red, 9 are green, and 3 are yellow. Ami is going to take a brick at random from box A and a brick from at random from box B. She is going to put these two bricks in a table, and we need to complete the tree diagram over here. Now we need to understand that these tree diagrams are for like, so these are for, like, replaced condition. I mean, whatever the number of bricks we're going to take out from box A or box B, they're not connected over here. If they're not connected, then this is for a replaced condition where the numbers are going to be same for box A and box B. Okay. So let me just write this down. This example, box A and box B are not connected. So this is for replaced method. Okay, in probability, I hope all of you know by this time, there are two types of probability in maths. One is not replaced and one is replaced, right? This is a situation for replaced maths. So this is not connected, which indicates this is a replaced maths. Probability. Okay. Now after this again, if we start with for, let me just write down the probabilities over here. As you already know, probability is basically the number of bricks you want in that category divided by the total bricks. So for box A we had 15 bricks. So for red it will be 5 over 15. For green it will be 7 over 15, and for yellow it will be 3 over 15. So I'll just write these numbers over here. For green it will be 7 over 15, and for yellow this is going to be 7 over 15. Okay. Now again after this, for box B we have the total as 20 bricks now. So for the red we have 8 over 15, 9 over 15, and 3 over 15, right? I'm not simplifying the fractions anymore. I mean, I obviously can, but I'm not going to simplify them, okay? That is not needed for me. Sorry, this was over 20 because in box 2 we had, or in box B, we had 20 total bricks. Now again, over here, I'll just write these numbers for this box B for the 3 hands actually. The numbers will not change. So this, for red, it is always going to be 8 over 20. For green, it is always going to be 9 over 20. And for yellow, it is always going to be 3 over 20. This is 8 over 20, 9 over 20, 3 over 20. Over 20, right? Now these are the values over here. We have completed the tree diagram clearly. Now after this, we're done with part A. For part B now, they want to calculate that the two bricks on the table are different colors. Okay. Now for different colors, there's one formula. For example, if you actually want to find out different colors, that will be what? Red multiplied with green, again red multiplied with yellow, right? Then again green multiplied with red, green multiplied with yellow. Then again yellow multiplied with red, yellow multiplied with green. So for different colors, you would actually have to find out 6 probabilities. That is quite big, lengthy over here. What you can instead do is that you can find out the same color and then subtract that same color from 1 to get the total number of different colors. Right, let me just write this down again. We can calculate part A, part B over here in two methods. First one is this red, sorry, 1 minute. Red multiplied with green and red multiplied with yellow, right? These are two different colors. Then again, green multiplied with red and green multiplied with yellow. Then again, we have yellow multiplied with green, yellow multiplied with red. You can clearly see in order to find out different colors, I would then have to find out the probability for 6 and then add them together, right? This entire thing will give you probability for different colors, right? But then again, if I want to find out the probability for same color, that is going to be what? Red, red, green, green, yellow, yellow, right? Simple, very simple for same color. Now, that is going to be red, red, green, green, yellow, yellow. And all of these things will add up to give you probability of same color, right? Now then again I can understand. 1 minute, let me just write this down at the very bottom over here. I need to understand that sum of all probabilities is always equals to 1, right? So in this particular mass, I only have two possibilities, right? Either the bricks could be of same color or they will be of different color. That means probability different color plus probability same color is going to be equals to 1, because that is the possibilities for all the cases that can occur in this maths. So probability for different color, I mean, we do not need to do very hard work to get the value for the 6 probabilities over here. Instead, we can use the shortest method, that is going to be 1 minus probability of same color. And from the tree diagram, I can easily get the probability for the same color, which is going to be 1 minute. Red, red, that's 5 over 19, so 5 over 15 with 9 over 20. Okay, so red, red is actually 5 over 15, 9 over 9 over 20. Then again we have green, green, 7 over 15 multiplied with 9 over 20. Oh wait, sorry. For red it was 8 over 20. And then lastly for yellow, this is going to be 3 over 15 multiplied with 3 over 20. Okay. Now using this 3, sorry, 1 minute. This is yellow, then this is green, then this is your red. Just delete these things. And now again, I would obviously have to subtract 1 out of all these things, right? So this is going to be 1 minus and everything. 1 minute. These will actually be added together. And they will have a second bracket on the outer side. And now if you just calculate over here in general, calculate the total value, you'll get it as 47 over 75. So this is your very simplest method that you can use in order to find out different colors for probability using tree diagram. Then after this, it is stated that Peter has a third box C, and this box also contains red bricks, yellow, green bricks, and yellow bricks. After taking a brick from box A and from box B, Ami then takes at random a brick from box C. Ami then puts this brick with the other two bricks on the table. The probability that there are 3 bricks on the table is this much. Find the least number of bricks there were in box C before Ami took a brick from the box. Okay. Now over here, that probability that all the 3 bricks on the table is going to be 19 over 1000, and we need to find out the total number of bricks in box C, right? So over here, I do not know exactly the probability for what yellow brick, right? I do not know the probability for yellow brick in box C. So for part B now, I just used a different piece. For part C now, probability for yellow in box C is going to be considered as X, right? I already know the probability for yellow brick in box A and B. For box A and B, they were like 3 and 15, 3 and 20, right over here. So for this case, probability for brick from box A, I'll just write yellow from A plus probability of yellow from B plus probability of yellow from C. This will be equivalent to that 19 over 1000. And for yellow in box A was 3 over 15 plus for box B was 3 over 20 plus this was X equals to 19 over 1000. And now this is going to be, if you just make X the subject of this, so 19 over 1000 minus 3 over 20 minus 3 over 15. If you calculate all of this directly on a calculator, 19 over 1000 minus 3 over 20 minus 3 over 15. 2 over 20, yeah, you're going to get 0.331. Wait 1 minute. No, actually, you're not going to like like add over here. They were saying that you are actually taking 3 bricks and placing them on the table, right? This is how you're doing this. Doing this, that brick from box A and brick from box B and brick from box C, right? So as I'm saying this and with a very tough intonation, that means these over here were actually multiplied. If these were multiplied with each other, in that case, they will be divided over here. So now using this again, same procedure, divided, multiply. Now you're going to get 19 over 30. Okay. So now you're getting 19 over 30. So the value for X turns out to be 19 over 30. Now 19 represents the number of red bricks in box C. This one represents number of, so not red, I think it was for yellow. In box C, and this 30 over here represents the total number of bricks, right? Now obviously we could calculate the value for the total number of bricks in box C, that is 30. So the final answer will be 30. Okay, this is your final answer. I hope this one was clear for all of you. No, I cannot fit in there. Let's just keep it over here. Okay, this was the working for um, first probability question from June 22 2PR. Now let's move on to the next question. This is from June 22 2PR question 5. Okay, now over here it is stated that Dan is going to play one game of squash and one game of chess against his friend, and the probability that Dan will win the game is this much. This is the probability for winning the game. That means if Dan would lose the game, right? For losing the game, the probability would be 1 minus win, 1 minus 3 over 5, that is going to be 2 over 5. Okay. And then again, the probability that Dan will win the game of chess is 1 over 3. And then again, losing the game of chess is going to be that 1 minus 1 by 3, which is 2 by 3. Okay. After this, we want to complete the probability tree diagram. Over here again, it was not related. Okay. In the question, it was stated that Dan will actually play squash and chess together. Dan is playing, like Dan over here is playing both. It is not like a condition over here that only if Dan plays squash, he will not play chess. If he wins squash, he will not play chess. Or if he loses squash, then only he will play chess. Okay, those would be the conditional probability, and for those, the probability tree diagram will be for the for those not replaced probability tree diagram, where chess and squash would be connected over here, chess and squash are not connected. That means this is certainly for your uh, replaced probability tree diagram will be connected. So this is still again not connected, and this will be for not connected, and what else? 1 minute. For replaced probability, right? Replaced probability tree diagram. Okay, for squash, winning probability was 3 over 5 and losing would be 2 over 5, right? We already calculated that. For chess again, Dan wins. Winning probability was 1 over 3. For losing probability, this was 2 over 3. As I've already always stated that for replaced probability, the branches are not dependent on each other, and whatever the value you write for this portion will be equivalent for the same portion again, for the next portion again. So this is going to be 1 over 3 and 2 over 3. This is the complete tree diagram. After this, now they're saying find the probability that Dan will win exactly 1. Okay. Exactly 1 means that either Dan can win this and lose this, or Dan can lose this and win this, right? That is the combination for exactly 1. There are also 2 combinations for exactly 1. Wins in squash, loses in chess, or loses in squash and wins in chess, right? That is the 2 conditions. So over here, for part B, wins in squash is 3 over 5. So 3 over 5 multiplied with loses in chess, that was 2 over 3. And this will be added to loses in squash, that is 2 over 5, multiplied with wins in, this is what, chess, 1 over 3. Right? This is, I'm going to write this as 1 minute, squash win and chess lose, and then again squash lose, chess win. Okay, CW represents chess win, SL represents squash lose, CL represents chess lose, and SW represents squash win. Over here, if you all multiply all of these things, you're going to finally get your answer as 8 over 15. That is your probability that Dan will win exactly 1 game out of this chess and squash. After that again, given that Dan won exactly 1 game. Now this is for conditional probability. Now I already know Dan is exactly going to win 1 game. That means your total probability over here is going to be 8 over 15, right? Now they're taking that, now they're going to pick up something out of this probability that, okay, Dan is going to play the game and Dan is going to exactly win 1 game. Okay, and what was the probability of winning 1 game? That was 8 over 15. And from this portion, now you're going to pick up some events. Second event is that calculate the probability that he won his game of squash. That means out of squash and chess, only squash will be win and not chess, right? So this is how the probability, conditional probability or probability given works. The probability, I'm going to consider that as option A, that I already know I'm taking my probability only from that portion A, right? Where I am entirely fixed on this fact that Dan will be exactly playing 1 game, like exactly winning 1 game, right? Dan will exactly win 1 game, and out of that probability, I want to choose out that exactly what was the probability of winning squash. So this is it. Squash, sorry, exactly 1 game given, exactly 1 game given. Sorry, this is supposed to be in this format. And in the first part, we are supposed to get that wins squash given exactly 1 game. Okay. Wins squash exactly given 1 game. So what was the probability? This is how we are going to write this. Probability wins squash divided by probability wins exactly 1 game which is now going to be wins squash is basically this one, right? Wins squash means obviously he is losing chess. So 3 over 5 multiplied with 2 over 3, and this will be divided by your 8 over 15, right? This is how conditional probability works. Now if you calculate, you're going to get 3 over 4. So the final probability that given that on Dan will only win exactly, or Dan will exactly win one game, and out of that he is now like winning only squash, not chess. So this is the probability over here. I hope this question was clear for all of you. Let's move on to the next question. This is from Jan 23 2P, question 10. Over here it states that a box contains 8 green counters and 2 white counters only. That means obviously that box has now 10 counters. Peter takes at random 2 counters from the box. Calculate the probability that Peter will take one green and one white counter. Okay, they have not provided you with the orientation that if Peter will take one green counter first or one white counter first. That means we have to find out the orientations also over here. So for part 10a now, probability one green and one white. Okay, for and I obviously understand we have to multiply this time. So first one will be green white combination, as we had what, 8 green and 2 white. This is going to be 8 over 10 multiplied with, since I already took out one green, that means now I have 9 balls available in that counter, right? So now this is going to be 2 over 9. And this is your case. Now again, the number of 2 did not change because in the first round I took out green. So the number of 2 white balls are still restored. But according to your total number, previously we had 10. And when I will take out 1, obviously there will be 9 left, right? And this will be added with like this, or white and green. For white and green, this is going to be again 2 over 10. This time I'm taking the white one first, and this will be multiplied with 8 over 9. Then again, if you just multiply all these things together and add the two fractions, your final answer will be 16 over 45. So that is the probability for taking one green and one white counter out of that, whatever it was. Okay, and out of that box. Okay, now after this, it says that a bag contains 28 blue heads and n red heads only. And Nasir selects a bead from the bag at random. Explain why the probability of the bead being red can be 6 over 11. Okay, we need to understand that it cannot be 6 over 11. Why it cannot be 6 over 11? Okay, bead for red cannot be 6 over 11. Okay, let's see. Now over here, for this bag, right, the total number of beads, is going to be 28 plus n, right? So n plus 28, and then again over here, I can find out, I want to find out the red number of beads, right? So for probability, the red beads, this is going to be what? N divided by n plus 28. And now I need to explain that why the probability for red beads in that bag would not be equals to that 6 over 11. So let's just start with the fact that, okay, if they are equal, then how would we continue for that part? For part B now, I'm considering that, okay, this is equals to that 6 over 11. And if that is the case, I'll cross multiply it, and it will be 11n, 6n, 6 multiplied with 28, that gives you 168. 168, right? And eventually 11n minus 6n, 168. So 11 minus 6 is actually 5n, 168, and 168 divided by 5 is actually a decimal over here. Okay, whenever you're going to divide this, 168 over 5, the value for n turns out to be 33.6. Now remember, the value for n was number of beads. and beads sorry, and beads are supposed to exist in whole numbers, in integer numbers, not in fractions or not in decimals, right? So according to this expression, if you're going to equalize the expression for the number of the probability for the red beads in that box or in that bag equal to the given probability, you get the number of red beads as a fraction, as a decimal, which is not possible. So this is not equals to each other, right? They should not, like n should not be equals to this 33.6. The final statement would be that n is 33.6, which is not an integer. So obviously probability for red beads in that bag could not be 6 over 11. Six over 11. Okay, that is your final answer. Now again after this, they are saying this that Nasir keeps the first bead and selects a second bead at random from the bag. The probability of both beads being different color is half. And given that there are fewer blue beads than red beads, okay, that means this statement over here gives you the idea that as the blue beads were 28, and now they're saying that there were fewer blue beads than red beads. This one gives you the idea that now n is actually going to be greater than 28, right? That is the inequality that they're providing to you, and now they want you to calculate that both beads are blue, and then you have to show clear working for it. Okay, now for this section, they have already given you that if the two beads are of different color, the probability was half, right? So we're going to use that concept over here. For part C, probability different color is equals to half, and that will be basically blue with red, or sorry, different color could be in different orientations also. That means blue white and white blue, right? These are the two orientations. And remember that doesn't matter blue white or white blue, at the end of the day they will give you the same value. So you just can write to this that blue white multiplied with 2, that will give you the two orientations for the two probabilities. Let me just write this down as a notes over here, that blue white and white blue can actually be written as 2 blue white. Okay, any one fraction, any one multiple can be multiplied with 2 to give you the total combinations probability. Now after here, different color, I'll write with blue. For blue it was 28 divided by total number is 28 plus n, and then this will be multiplied with n plus 28. Right, this one gives you for one orientation. I'll just multiply it with 2 to give you the value for two orientations, and that is equals to half. I can understand this half and 2 will get cancelled each other out, and inside the brackets now you can take the total denominator as a whole, so which will make, oh no, sorry, we cannot do that. No, we can do that. Like this time it's going to be n plus 28 whole square and 28n equals to 1. If you cross multiply them, this is going to be 28n equals to n plus 28 whole square, which is now going to be n square 28 multiplied with 2. That is 56. N 28 square is actually 784 equals to 28n. If you take all the n's together, that's n square. 56 minus 28 is actually again positive 28n plus 784n. Now I can clearly understand I have to do middle term over here after this point. So which is going to be 1, 28 and 784. That is, wait 1 minute. Wait 1 minute. 2 with 28, that is 256. We had 1 on the other side. 2 with 28n. Oh wait, I actually made a mistake over here. 1 minute. This was actually for a case for, this entire math was actually for not replaced. That means if I'm going to take one blue bead out of the bag, Previously, if I had maybe like X number of beads inside the bag, after taking one out of the bag, now the total number of beads inside the bags will be X minus 1, right? As I already took one out of the bag, the total number will decrease by 1. So in that case, over here, we are supposed to write this as n plus 27, right? This time it will not be 28 because I already took one out of the bag. So this becomes 27. Now it will be 28n divided by n plus 28 n my plus 27. This is equals to 1. And now if you do cross multiplication, you're going to get 28n and then n square 28n, then 27n. 28 multiplied with 27 turns out to be 756. Okay, 1 minute. This is n square, 27n, 28n. Wait, 1 minute. Sorry guys, I again made a mistake. 1 minute. This 2 and 2 will not actually get cancelled out. It will actually be in this format, that on the right hand side obviously you're going to get 28n divided by n plus 28 and then n plus 27. Okay, and then on the right hand side now you're going to get 1 over 4. Now if you just cross multiply it, this 4 gets multiplied with 28n and this is going to get to n square, 28n, 27n plus 756. Okay, now from this point onwards, 28 multiplied with 4 turns out to be 112. So now you have n square plus 28n plus 27n minus 112n plus 756 equals to 0. And now it will look like this: n square minus 57n plus 756 equals to 0. From this part, if you do the middle term, if you continue with the middle term, you're going to get the value for n, like the two factors format will be n minus 21, n minus 36 equals to 0. From this part, I can understand that n is equals to 21 or n is equals to 36. It was already provided in the last part of the question that the number of red beads is greater than the number of blue beads in the equation. So n is actually greater than 28. According to this condition, this doesn't obviously fit in with the condition. That means n can never be equals to 21, right? N should be equals to 36. So this is your final answer. In that bag over there, you had 36 red beads. This is the final answer over here. I hope this one was clear for all of you. This was from Jan 23 2P question 10. Let's move on to the next question. This is again from Jan 23 2P R question 6. And let's start with this. Over here, they have provided you with that Ted has two boxes of buttons, box A and box B. There are 20 buttons in box A and 20 buttons in box B. There are 13 white buttons in box A and 9 white buttons in box B. That means the probability for white buttons in box A is 13 over 20 and the probability for 9 white buttons in box B is 9 over 20, right? So Ted takes at random a button from box A and a button from box B. We need to complete the tree diagram. Over here, this is for also for that replaced condition, right? It will be not related, like whatever the value of button you take from box A, that is not related to box B. So for box A, if taking is 13 over 20, right, that means not taking is going to be 1 minus 13 over 20, which is 7 over 20. And then again over here also, not taking. Not taking means that if Ted was not taking wide buttons from box B, then that would be 1 minus 9 over 20, which is 11 over 20. Okay, this is how the entire thing would look like. So for box A, it was 13 over 20. For not white, this was 7 over 20. And for box B, this is white. For box B, white is going to be 9 over 20. For not white, this is going to be 11 over 20. This is 9 over 20 and 11 over 20. Okay, this is how the tree diagram looks like. Now after this, it says that calculate the probability that Ted takes at least one white button. Okay, now over here, at least means that on minimized version, Ted can take one white. That means on a maximized level, Ted can take two whites from the two bags, right? So at least means that one white or two white. Okay, but there will be no zero white. The condition is like this: at least indicates that Ted can take one white or two white but not zero white. Okay, now this is the condition over here. For this condition, one white means that it would be what? Again, one white has orientations, right? White, not white, not white, white. That is for one white. And for two whites, this is going to be white, white, right? That is the condition. So problem is for at least one white has a lot of works to do, right? For at least one work, you have to do what? You have to consider taking white from A and then not white. I'll just write not white from B, right? And then you have to add this with white from B and then not white from A, and then again add this with white from A, white from B. These were the given probabilities for at least one. Okay, and if the opposite of at least one would be that that opposite of at least one white would be that Ted will not take any one. Ted will take 0 1. 0 1 means that Ted will take not white from both box A and box B, right? So not white box A multiplied with not white box B. And obviously these are the four probabilities that should be equals to 1. So using this, I'll just actually move on to the next page. This is for option B, by the way. Okay. Now using this over here, I can understand that the first 3 was actually used for at least white, right? 1 minute, let me just highlight this. But these three, this was actually creating your probability at least one white. Okay, these three was for the same condition of at least one white, and that will be added with what? Probability no white. Okay, and that will give you 1. Okay, again you can obviously use this concept that 1 minus no white will give you the at least one white, right? So there is no point of separately calculating the three probabilities and then adding them together. So the easiest way out over here it should be that at least one white is going to be 1 minus probability no white. Okay, for no white, if you go back to your tree diagram, no white is 7 by 20, 11 by 20, right? No white, no white. So it is now going to be 1 minus 7 over 20 multiplied with 11 over 20. Okay, and that is again for the probability of at least one white. We at the end want to satisfy the equation, right? We don't want to find out the specific probabilities, three probabilities over here. We're not looking for that. We're just trying to satisfy the equation. And if you can do this over here, that will easily give you the value as 323 over 400. Okay, that is your probability of at least one white. Okay, now this is it for part B. I hope it was clear. Now let's move on to part C. Before part C, they have a very big statement. It says that Ted also has a bag of buttons. There are 30 buttons in the bag and there are X white buttons in the bag. Okay, that means in the bag the probability for white buttons would then be X over 30, right? That I can clearly understand. And Ted takes at random a button from box A, a button from box B, and a button from the bag. The probability that the three buttons Ted takes, two of them are white, right? Two of them are white is this. Now two of them are white should be means what? Two of them from maybe this. These are the actually conditions over here. White from A, white from B, and not white from I'll consider the bag as C. Okay, the bag as C. So this is C, and then again other could be white from A. Okay, I'll just okay, using this knowledge you just have to calculate the value for X. Okay, so I'll just start writing down the answer over here. 337 over 1000. Okay, 1 minute. I'll start writing the answer over here. This is for C. Probability 2 whites. 337 over 1000, and over here I'm taking this box A, box B, and the bag as box C. Okay, just for my simplicity I'm considering this. Now from this part, 2 white actually indicates white from A, white from B, and not white from C. This will be added to white from A, not white from B, and white from C. And then again this will be added to not white from A, white from B, white from C. This will be 3371000. Okay. Now again if you remember white from A and white from B, that was what? White from A was 13 over 20, white from B was 9 over 20. Okay, 13 over 20 and 9 over 20. So over here we are going to write 13 over 20, 9 over 20, and for box C or bag X, or from that box, it was supposed to be X over 30. Okay, and then using this I can find out white from A is still 13 over 20, not white from B is now 11 over 20, and white from, oh wait 1 minute, not white from bag C or this box C is actually going to be 1 minus X, right? This is supposed to be 1 minus X or 30 minus X, not 1 minus X. 30 minus X will give you all the other buttons other than white. So this is supposed to be over here as 30 minus X. And now for white from that bag C is going to be 30 over X over 30. Okay. And then again lastly, not white from A is 7 over 20. As I was saying, 7 over 20. Then white from B is 9 over 20 multiplied with X over 30. Right? And that should be equals to that 373 over 1000. Now then again from this part, if I start calculating over here, from the first expression, we are going to get 1170 minus 39x divided by 4000 plus 143x divided by 12,000 plus 21x divided by 4,000. And that should be equal to this 373 over 1000. Okay. From this part again, if I take the entire denominator as 12,000, it will be actually 3 multiplied with 1170 minus 39x plus 143x. Nothing will be multiplied with this because for this the denominator was already 12,000, and then 3 again multiplied with 21x Now eventually we are going to get this as the final answer should be in this format. 1 minute. Like 3 multiplied with 1170, that turns out to be 3512 minus 3 multiplied with 39 is 117x plus 143x. 3 multiplied with 21 is 63, and this 373 over 1000 multiplied with 12,000. So this is 373 over 1000 multiplied with 12,000. That is 4476. So on the right hand side, I'm going to get 4476, and on the left hand side, 3510 1 minute. Minus 117 143 63. That is 89x and 3510. And this should be equal to, the value for x should be 4476 minus 3510. That should be divided with 89. 4476 minus 3510 divided by 89. And that is equals to, oh wait 1 minute. Sorry, I think I did some mistake over here. The part over here was 337 or 373. So in that case, 337 by 1000 with 12,000 turns out to be 4044. 4044 minus 3510, that is 534 divided by 89, that turns out to give you 6, and that is your final value for x. Okay, the number of white beads in that last bag was actually 6. Okay, this is your final answer for this probability question. I hope this was clear for all of you. Let me just scroll over for this last question, Jan 23 to PR, and this is the entire working. Okay, now this is again a probability question. This is kind of like pie chart and probability mixture. Okay, now over here we have this from June 23 2P. They have provided you with the pie chart with angle for 272, and a bag contains red bricks, yellow bricks, and green bricks only. The incomplete table and an incomplete pie chart give information about the colors of the bricks in the bag, and you need to find out the number of red bricks over here. Okay, for the number of red bricks, 1 minute. The number of red bricks. Okay, they have provided you with the total number of bricks, that is 130. And from a pie chart, I know the total angle is what, 360, right? So you just have to compare that red bricks angle with the total information over here to get the value for the number of red bricks. So for part A now, I'm going to create an equation like this as I'm trying to find out the number of red bricks. So it will be red bricks divided by total bricks angle for red divided by angle for, or total angle actually should be a better word, but I'll just keep it like this. Now for red bricks, I do not know the value, how many red bricks there were in the bag, but I do know the value for the total number of bricks, which is 130, and the angle for red bricks was 72 degrees, and the angle for total was 360 degrees. Okay, that means for this part, I'll just make that red bricks the subject of this formula, and that will be 72 over 360 multiplied with 130. From this part, which is going to be 72, 360 with 130. That will give you 26. That means at the end, in that bag, you had 26 red bricks. That is for part A, and after this it says that a box contains 9 red bricks and 6 green bricks only, and Asha takes a brick from the bag and a brick from the box. Okay, 1 brick from the bag and 1 brick from the box. Complete the following tree table and again complete. Okay, first complete the tree table. Okay, 1 minute. It is also stated that if green is 50 over 130, non-green is obviously going to be what? 1 minus 50 over 130, right? Which is basically going to be 1 minus 50 over 130, that is 8 over 30. And then again, for box also, if green is 6 over 15, not green is going to be 1 minus 6 over 15, which is going to be 1 minus 6 over 15. That is 3 over 5. Over here, not green for the box portion would still remain the same, 6 over 15, 3 over 5. We have completed the tree diagram, and after this, it states that complete the probability that exactly one of the brick is green. Exactly one means that there has to be specifically one. There could not be more than one. Okay, exactly one. Exactly one of the bricks is green. That means it could be this green and not green, and this not green and green. Okay. So at the end, for part C now, probability exactly one green is actually this 50 over 130 multiplied with, always remember the probabilities which are on one hand, 1 minute, which are on one hand are going to be multiplied, and the probabilities on the other hand will be added with the first one. Okay, so 50 over 130 with 3 over 5, and this will be added with your 8 over 13 multiplied with your 6 over 15. Okay, now 50 over 130 multiplied with 3 over 5, 8 over 13 multiplied with 6 over 15. And if you calculate all these things, you're going to get the final answer as 31 over 65. That probability for exactly one green is 31 over 65. Okay, that is your final answer. So we are done with this probability question also. Let's move on to the next one. Okay, for this one, this is from June 23 to PR question 10. Okay, now he says that Hugo is learning a new game. Each time he plays the game, the possible outcomes are that he may win, draw, or lose. There are 3 options. The first time Hugo plays the game, the possibilities that he wins is 1 by 4 and draws is 1 by 12. That means over here from this part, if he loses, that will be what? 1 minus 1 by 4, right? Oh, wait, no, what? That will be actually 1 minus these 2 probabilities. Okay, so the probability of lose is actually going to be 1 minus 1 by 4 minus 1 by 12, and that is 1 minus 1 by 4 1 by 12, which is going to be 2 by 3. So the probability for losing the game for the first round is 2 by 3. And that was the working for part A. Actually, we did this. This is the working for part A. After this, for the second round, Hugo plays the game, and the probability that he wins, he draws, he loses are given. He wins, he draws, he loses. You have to use this information to complete the following tree diagram. So the tree diagram over here, I know for the first round, if he wins, the probability was 1 by 4, draw was 1 by 12, and lose was I already calculated in part A, that was 2 over 3. And for second game, it was already given in your question, right? Winning probability was 3 over 5, 3 over 5, and 3 over 5. This is again a not. So this is again a replaced condition. That means the first round is not related to the second round. Draw was 1 over 10, 1 over 10, 1 over 10, and losing was 3 over 10. We have completed the tree diagram. Now after this, we'll move on, and for this part, he says that Hugo plays the game twice, find the probability that he draws both of the games. That means just basically draw multiplied with draw, right? For draw multiplied with draw, if I go back to the tree diagram, this is 1 by 12 draw, this is 1 by 10 draw. So for entirely to draw the game for the 2 rounds, you just have to multiply draw with draw. Draw and draw. So for C now, this is just going to be probability draw, that is 1 over 12 multiplied with 1 over 10, which is I think 1 over 120. And that is your final answer for part C. Then Hugo scores point each time he plays. He scores 3 points if he wins, 2 points if he draws, and 1 point if he loses. After 2 games, Hugo has 3 points. Okay. Now the combinations of 3 points can be in any order. You need to find out that how did Hugo got 3 points. Okay. After 2 games, he has 3 points, right? That means he obviously did not win in the first round, because if he did win, then he would have easily got 3 in the first round, right? Oh wait, yeah, there could be one chance over here of getting 3 in 2 rounds. That is, in the first round, oh no, the losing part is not 0. The losing part is 1, right? That means there's only one case, 2 plus 1, 1 plus 2, right? He can either draw and lose or lose and draw. That are the only positions or combinations over here that is possible. But they're giving you 5 marks for it. After 2 games, Hugo has 3 points. Find the probability that Hugo lost the first game. Oh, sorry. Do you want to find out the probability that Hugo lost the first game? Hmm? Find the probability that Hugo lost the first game. Wait 1 minute. He scores each time he plays. He scores 3 points if he wins, 2 points if he draws, and 1 point if he loses. Okay. And after 2 games, Hugo has 3 points. Find the probability that Hugo lost the first game. 1 minute. This is actually like one of those conditional probability. Okay, they're giving you the first concept, first condition, that he will play 2 games and his total score after the 2 games is going to be 3. So let's just find out that the first condition. Let's clarify the first condition, that probability 3 points after 2 games. Okay, and that will be 3 points after 2 games is going to be either he will lose and win, so lose and draw, or draw and lose, right? 2 plus 1, 1 plus 2 is going to get you 3. So it's going to be, let me just break this down like this, 2 plus 1 or 1 plus 2, right? 2 is for draw, 1 is for win, 1 is for lose. So in that case, it could happen in this way, that he might lose. So he might get draw in the first round and then lose in the second round, So for drawing the first round, the probability was 1 over 12 multiplied with 1 over, losing in the second round was 3 over 10. And this will be added with lose in the second round, that was 2 over 3 multiplied with draw in the first round, that was 1 over 10. And that will give you 11 over 120. Okay, now again from this part with 11 over 120, this is your first condition, that now you have to find out that what was the probability that Hugo will lose the first game, given that this is the probability. Okay, this is the probability, conditional probability is this: Hugo loses first game given that Hugo loses first game given that um, he scores 2 points after 2 games. Okay, he scores 3 points after 2 games. This is basically going to be now, I'll just write it down over here. No, I should write it down over here. Now for this part, this is going to be the denominator, which was 11 over 120. 1 minute. Okay, now in the denominator, it will be, wait, there's actually sweat on my screen, so I cannot actually handle that properly. Maybe now I can write it down over here. This is supposed to be 11 over 120, and on the numerator you are supposed to get losing, like you need to lose in the first game. If he loses in the first game, that means obviously the second game he needs to draw, right? That in that case, this is supposed to be lose and draw, right? This portion over here actually indicates lose and draw. Okay, so lose and draw probability was 2 over 3 multiplied with 1 over 10. And now if you calculate this, then you will get your final probability as 8 over 11. And this was actually a conditional probability. Right? For conditional probability, this is how we are going to calculate. I hope this question was clear for all of you. And if there is any question, please reach out to me through comment section. I'll try to reply as fast as I can. Now this is again the last question from probability, I think. Yeah, this is the last question from probability. Now then set starts. Okay, so let's start with sets. For sets over here, this is from Jan 22, paper 2, and in this question, this is from question 8. It says that there are 62 students in a drama group, and all 66 students in a drama group take part in at least one of the 4 activities given below. That is either acting, dancing, singing, or stage management. Okay. Now over here, of these 66 students, 11 take part in acting, dancing, and singing. That means 11 over here is going to be at the very center, and this is done. Then 17 take part in acting and singing. For acting and singing, wait 1 minute. Management was not added in the Venn diagram already, right? We just have acting, drama, and singing with no management, and 17 students are taking place in acting and singing. Okay, so this is for acting and singing. 14 take part in dancing and singing. So 14 take parts in dancing and singing. 16 take part in acting and dancing. So 16 take part in acting and dancing. 33 take parts in 16. Over here, 33 takes part in singing means that in this entire total, right, that is equals to 13. Like whatever the only people who was taking singing, I'll consider that as x, and including that x plus 17 plus 11 plus 14, all of these are going to be equals to your 33. So I can easily make an equation and get the value for the x over here. X represents the number of people who were just taking singing, right? That represents that the only people who take singing. Also 1 minute. Now over here there's another one thing. Now as you can see from if I actually follow that procedure, that is for singing, I had 33 students in total. So it is going to be x plus 17 plus 11 plus 14, that is equals to 33. 33. Now over here, if you just add up this 17, 11 and 14, you see you get 42 over here. Now how come this part would be greater than the total number of students who took part in 16? That means this is completely wrong. We did something wrong over here. The wrong part over here was this portion. That means whenever they're going to give you the total, like at the center over here, like all of the all of the union parts, like A intersect A union, D union, so not union, intersect A intersect D intersect S. They have given you that 11 students took part in all of the activities, acting, singing, drama. That means you have to subtract these 11 from all of the three other two activities student. That means over here, this is not going to be entirely 16, 14, 17. This is going to be 17 minus 11, which is now going to be 6. Okay, and this is not supposed to be 14. This is supposed to be 14 minus 11. That's 3. Then again, this is not supposed to be 16. This is 16 minus 11. That's 5. So this is your final answer. Okay, 5, 3 and 6. And then again, I can get the value for x easily now. That is going to be 1 minute. X plus 6 plus 11 plus 3 equals to 33, which is now going to be x equals to 6 plus 11 plus 3, that is 20. So 33 minus 20, which is going to be 33 minus 20, minus 20, that is equals to 13. So the value for x is now 13. That means the number of students who just took singing and nothing else was 13 students. So this is for 13 students. Okay, so we have we included all these things in your Venn diagram. And again, after this, there are 37 students that take part in acting. That means all of this is acting, right? So I'll consider that as y. So for acting now, I have 37 students. For acting, I have 37, and acting can be broken down using y plus 5 plus 6 plus 11, and that is equals to 37. So we get y as 37 minus 5 plus 6 plus 11, so which is 22. So 37 minus 22, which is 15. Y is 15 now, so this portion you have 15. And then again 29 take part in dancing. That means over here this is Z. Okay, I'll consider the dancing as Z. Now this is going to be dancing. The total number of students who took part in dancing was 29, and that can be broken down as Z plus 5 plus 11 plus 3, that's 29, and which is going to be Z equals to 5, 11, 3, that is 19. So 29 minus 19. So 29 minus 19 is 10 again. So the value for Z is 10. Okay. Now this is the value for 10. Let me just input this over here again. And we have inputted this into your Venn diagram again. But then again, we started with 66, right? So let me just like count up that does all these values end up to give you 66 or not. For example, over here, this is 10, 11, 15 and 13, right? So I'll just add all the values on my calculator. That I have 15, 5, 10, then 6, 11, 3 and 13. 15, 5, 10, 15, 5, 10, 6, 11, 3 and 13. That tends to give me 63, but I started with 66 students, right? That means 3 students did not take part in anything. 1 minute, let me just write this down over here. Okay, whatever it is, let me just write this down. That total was 66. That is going to be basically, now this one turns out to be, I'll consider this one over here as whatever the number of students who did not took part in anything, that I'm considering as not M, because M was actually taken for management. I'll consider this as P. Okay, for P plus all of these numbers is actually 63. I already know. So 63 equals to 66. In that case, P turns out to be 3. So on the universal sets, you're going to get 3 students who did not took part in any of the 3 activities: acting, dancing, and singing. Now after this, it says that find the number of students who took part in management. Okay, these are the number of students who took part in management, stage management. Because over here, this is obviously for the universal set, and they were also saying that acting, singing, dancing is actually a subset of stage management, right? Because these activities will be played on stage. So that's why this entire universal set turns out to be your stage management, and inside that you have acting, singing, and dancing. That means people who did not take part in acting, singing, dancing were indirectly taking part in the stage management. So we now get um, what is this number of students who did not take part in acting, dancing, or or singing, but did took part in stage management was this 3 students. Okay, this was actually the working for your part 1. Sorry, this is B part 1. Okay, now then again they want to find out A intersect D prime union C. Okay, D prime is basically cancellation of this, and if you want to intersect this with Y, that is going to be what, 15 and 6, right? A intersect D prime is 15 and 6. Let me just write this down for B part 2 now. A intersect D prime is actually 15 plus 6, and then union of S. Union of S means we're just going to combine this with S. S had already 6, sorry, 1 minute, 15 and 6, right? And union of S, right? For union of S, this 6 is repetitive. So obviously we're going to take repetitive parts twice. We'll only take that one. So I'll just write this down. This one is actually 15 plus 6, and A intersect D prime union S actually gives you 15 plus 6 plus 11 plus 3 plus 13, and that gives you 33. Okay, 1 minute. 15 plus 6 plus 11 plus 3, 15, 6, 11, 3, 13. Sorry, this gives you 48. Sorry, miscalculation. This gives you 48. Okay, that is the working for your part B2. Now let's just take this and place it at the very bottom because this is not needed over here. For part B3 now, for part B3 it says that A intersect D intersects S prime and then entire prime. Okay, for A intersect D intersect S prime. S prime means everything other than S, right? Entire S will be cancelled out. So A intersect D intersect S prime is basically just 5. Right? A intersect A intersect D intersect S prime is everything other than 5. So for this A intersect D intersect S prime is just 5, and then again you are using the prime of that, right? So basically you are going to get everything other than 5. You're going to use everything other than 5. Okay, so let's just do this over here, that A intersect D intersect S prime, this is actually 5, and now they want to find out the prime of this, right? So prime of this means that A intersect D intersect S prime whole prime is basically total minus A intersect D intersect S prime, which we got in the previous part as 5. So this is just 66 minus 5, answer would be 61. So this is your answer, 61 for B part 3. Okay, now over here, one of the students in the drama group is selected at random, and given that the student takes parts in dancing, okay, it is already stated that one of the students from the drama group is selected at random, and it is already given that the student is already taking part in dancing. So out of the dancing, now you are taking students, right? Out of the dancing club, Now you're taking students who are also going to take part in management and also going to take part in singing, right? That is your condition. Like dancing given stage management, and then again dancing given singing. That is your conditional probability case over here again. Now if you go back, 1 minute, find the probability that this student also takes part in stage management, right? We are taking students from dancing, and out of dancing it is also taking parts in stage management. Now we can understand that there was no intersection between D and management, right? So this is how it looks like, that probability stage management given dancing, right? This is how it looks like, the probability of management intersection of dancing divided by probability of dancing. Obviously probability for dancing was 29, right? There were 29 students in the entire dancing club, but there were 0 students in between the intersection for management and dancing, because as you can see, D and this one doesn't intersect. So obviously in the numerator now you're going to get 0, and in the denominator you have 29, but eventually the answer would be 0. Similarly, for the singing part now, this is actually probability singing given dancing. For singing given dancing, they now have a probability intersection. The probability is intersection D divided by your probability D, right? Obviously, in the denominator, we still have 29, the total students in the dancing club. And now this is your intersection for DNS. That is what? 11 and 3 over here, if you can see. So this is 11 and 3. So it is just going to be 11 plus 3. So 11 plus 3. That's 14 over 29 then. 14 over 29. That is your final answer. So this is it for the first set question. I hope it was clear for all of you. We'll move on to the next question very quickly. And if there is any question, please do not hesitate to reach me out through the comment section. And yeah, this is it. Let's move on to the next question. Okay, now this is from June 22 2P. It has given you that the universal set A, B, and C are, and like these are the 3 sets under the universal set. And universal set contains P, Q, R, S, T. A contains QRS and B contains PQT. We need to find out A intersect B. A intersect B, we have to find out the common parts. For common parts, A and B only have Q in common, right? This Q and Q. Yeah, other than that, they do not have anything else in common. So only intersection is Q, particle Q or element Q. So this is just going to be Q. Okay, element Q, and A union B is the combination, but when in combination, in union, we do not write the repeated element twice. Okay, so for this one it will be actually P Q R S T, right? That is the union of A union B, and then again A prime intersect B. Let me first explain what is A prime. A prime is basically everything other than A in the universal set. So in A you had QRS. So if you subtract QRS, now you have PT. So A prime is actually PT. Okay, this PT is going to intersect with B, which was PQT. Okay, now then again, the intersection over here is going to be what? PT and PT, right? So for this A intersect B is actually going to be PT. So now I can write, 1 minute. Therefore, A prime intersect B. A prime intersect B is actually P and T. These are the elements that are common between the sets A prime B. Okay, and then after that, this is the part A. Okay, this was part A. This is done, and now after this, for part B, now they have a statement given that A intersect C is just R, element R. Now it was never given in any sections in any previous part that set C was not mentioned, right? I mean, there was set C, but only set A and set B was given, set C was not given. They have only providing you with one idea that A and C has this R common. Now, we have to understand one thing over here, that if element A and C have only one element common, that means other elements in A, P, Q and S was not there in element C or set C, right? Other elements in set A, which is Q and S, was not in set C. If they were in set C, they would appear in the intersection over here, right? Intersection set, but they are not. Only R is there. This gives me with the indication that only R is the element that was present in C, that was also present in A, right? That was also present in set A, and other elements in set A, that is Q and S, was not present in set C. That's why the only intersection for A and C gives you R. Now you need to find out all the other possibilities of set C. Now you can clearly understand that over here, as a universal set was what? 1 minute. P, Q, R, S, T. Right? And now from this A intersects C concept, I already understood that Q and S will not be in A, because if it was, then it will also remain, or it will also show in this portion, right? As Q and S was elements from particle A, was elements from set A, right? So this one indicates that Q and S are not in set C. As if it was, then they will also appear in the intersection for A and B, right? Now for this, I can only understand that Q and S will never be in set C. So there are possibilities that P, Q, T will be in different combination, will create the all possibilities for set C. So the first, over here again, there was nothing given as that there could be one element in set C, there could be two elements in set C, or there could be three elements in set C, right? So we're going to find out the different possibilities. If I'm going to consider that there is only one element in set C, that has to be R, right? Because it was already given. So set C, that could be just R. And then again, if I consider if there were like two elements in set C, that is going to be either PR or RT, right? And there is another last possibility. There could be three elements in set C, which is PRT. Right? So these are the four possibilities that set C could have. Okay, these are the four possibilities of list of elements that set C could have. This is your point B. Okay, now after this, for set C now, one of the possibilities for set C is selected at random, and they have also provided you with the condition that find the probability that this set C is such that C and B will not have anything in common, because they are providing you with that set B intersect C is a null set. Over here, if you remember, set B was actually P, Q, T. Right, PQT was your set B, and they were also saying this that, over here, if I can understand that from this set, P is common with B. From this set, T is common with B. From this set, P and T is common, right? That means if I'm going to choose any of these sets for C, any of these three sets for C, then B intersect C will not be null set, right? For only one set, for only this set, the B intersect C is null set, right? So out of the four sets, only one set, only one possibility of set that I calculated matches with my condition that B intersect C is 0. So in this part, if I want to choose one possibility of C out of the four I got in part B, and that also matches with B intersect C is null set, then this is the set they're talking about. And what would be the probability of choosing this? This is obviously 1 out of 4, right? So final answer over here is probability of set C, and the given condition was what? B intersect C null set, right? This one was just 1 out of 4. That is your case for sets in this question. I hope this was clear for all of you. We'll move on to the next question very quickly. Okay, for this one, they have already provided you with the diagram filled with the like they have the entire filled up Venn diagram. I think we just have to find out the numbers, right? This is from June 22 to PR. This is the first question, so it is supposed to be easy, right? Now over here, they are saying that the Venn diagram shows information about the numbers of students in a school who study history, music, and geography, and find the number of students who study geography. Only geography they're talking about. For only geography, this is the portion. right? This entire circle over here is for only geography. And from this circle, I can clearly understand there are like how many elements? 4 elements, right? 11, 3, 6, 21. So you just add these together. This is 11, 6, 3, 21. And that is basically 41. Then find the number of students who study exactly two of the subjects, history, music, and geography. History, music, like two of the subjects means what? They're talking about this, right? Either 12, either 6, or either 30, either 11. Okay, but not the three students at the center who's taking all of these three subjects, right? Only two subjects. That means he could take music and history, and music and geography, or history and geography. So 12, 6, and 11. So that is going to be 12, 6, and 11. So 12, 6, 11, that is 29. And then again on the Venn diagram above, shade the region that represents H intersect G prime. Okay. Now for this part, as we need to do shading, let's remove all these things. And H intersect G prime. Now H intersect G prime. G prime means that obviously everything other than G, and intersection means that only this portion. Wait 1 minute. H intersect G prime, right? Yeah, this portion will be entirely. Right, this is H intersect G prime. Now this is it for part C. So we will move on to the next portion. Okay, now this is again a continued version of question 1. In question 1 now it says that universal set has set A and B, and universal set contain elements from 1 to 10. A intersect B is all multiples of 3. All multiples of 3 means what? They are 3, then sorry, should be in underset notation. 3, 6, 9, 369, right? Only 369, nothing other than that. And A intersect B prime is this, and A union B prime is 1 and 7. We have to fill this over here. A intersect C, so A intersect B is 3, 6, 9. A union B prime, A union B whole prime means they will be in the universal sets 1 and 7. And A intersect B prime. A intersect B prime means what? Only this portion, right? Only in A. A intersect B prime means that only the elements inside A, which is going to be 2, 4, 8, 10. Now if you can see that 1, 2, 1, 2, 3 were already in set. 4 is already in set. 5 is not in set. So 5 will be in B. Then 6 is already in set. 7 is already in set. 8 is already in set. 9 and 10. Right. So in only B, 5 will be there. Nothing other than that. So we have filled up the information, and now they want to find out the elements in only B. Only B is now going to be what? 3, 6, 9, and 5, right? This is your, oh wait, sorry. It says number of elements in B. Number of elements in B means that count down the number of elements. 1, 2, 3, 4. There are 4 elements over here. So finally I can write 4 elements, right? So this is it for your question 1 from June 20, what was this year? Yeah, June 22 to PR, right? This is your question 1. Okay, now after this we'll move on. This is from Jan 23 2P, question 7. Okay, now over here it says that universal set is all the odd numbers between 0 to 30. And let's just list down this, okay, all the odd numbers from 0 to 30. That is 1, 3, sorry, yeah, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, and 29. Okay, this is all the odd numbers between 0 to 30. And among this, all the three like multiples of 3 is under set A. that is 3, 9, 15, 3, 9, 15, 21, 3, 9, 15, 21, then 27. Okay, these are all the multiples in set A. Then prime numbers are 1, 3, 5, 7, 11, 13, 17, 19, 29. Okay, these are all the prime numbers, so this will be in set B. And set C is factors of 30. Factors of 30 is obviously 1, 3, 5, 15, just 1, 3, 5, 15. But other than that, no other elements will be factors of 30. Now we need to complete this Venn diagram. Okay. For this one, I can understand that 3 over here goes for all the numbers, right? 3, 3, 3. So 3 will be in the center. This is 3. And then again, A intersect B is basically, no, other than 3, we do not have anything in common for A, B. But for A and C, we have 15 common, right? So we can write 15 over here. And then again for B and C, we have 5 common, right? So we can write 5 over here. And 3, 5, 15 is already given. So from C, only 1 is present. I'll just write that 1 over here. And yeah, for B again, 3 and 5 is gone. I have, wait, for prime numbers, they're not actually taking 1, okay? Sorry, for prime numbers, this is not going to be 1. This is just 3. And 3 and 5 are already gone. So I have 7, 11, 13, 17, 19, 29. So these are the 6 numbers that will be only in set B. And in set A, I have out of 3 and 15, I have 9, 21, and 27. And then again, out of all these things, if you can see that, oh wait, 1 minute, 23 is also a multiple of 3. Wait, is it? No, wait. 23 is not a multiple of 3, but 23 is a prime number. So I'll just write 23 over here. Right, so I get 23 over here. So you can see all of the numbers are actually in any of the set except 25. That means 25 will be under this universal set. Okay. Now after this, now they are trying to calculate A union B intersects C. Okay. For A union B, sorry, A union C. Okay. For A union C, that means 1, 2, 3, 4, 5, 6. Right. These are the intersection, and so these are the union. And if you're going to intersect this with B, that means only this 3 and 5 will be common, right? A union B intersects C. A union B intersects C is actually talking about these portions. A union C intersect B is only talking about these portions. And I can clearly see in these portions only 3 and 5 was common. And we need to find out the number of elements, not the summation of the elements. So 3 and 5 will give you 2. Right? So in that case, I'll just write down that n 3, 5, and which is basically 2. Then again we have B intersect C prime, union A prime. Okay, 1 minute. B intersect C prime. B intersect C prime is actually this portion. Okay, this is actually B intersect C prime, and that has to be again in union with A prime. In union with A prime means that is 21, so 25 will also be there. So if this 25, oh wait, right, this in union with, yeah, this with union with A prime means this after it actually has to be union with A prime. For A prime again, this further portion will be finally like mixed. Okay, like everything other than A, right? It will be everything other than A, like everything other than A. That means for everything other than A, how many elements do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, everything other than A. This entire thing, A intersects C prime. So B intersects C prime union A prime actually indicates everything other than A. A very easy word would be A prime. Okay, that will also give you the same number of elements. That's 7, 11, 13, 17, 19, 23, 29, 5, 1, 25. So 1, 25, 7, 11, 5, 13, 17, 19, 29, and 23. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. So this is 9, 10 elements. So just remove all this shading. Now then again after that it says that a number is chosen at random from the universal set. Write down the probability that the number is in the set C intersect A prime. Sorry, yes, C intersect A prime. C intersect A prime. That means it will just be 1, right? C intersect A prime is just 1. And this is going to be 1 and 5. Okay, for this one, C intersect A prime is actually 1 and 5. So what do you have? 1 and 5 is 2 elements, right? Out of how many? 2 elements out of the total number of elements over here. So the total number of elements were 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, which is like 14 elements there were. So out of 15 elements, out of 15, this only represents 2. So probability over here turns out to be C intersect A prime is actually 2 over 15. That is the probability. Okay. Now for part B again, given that the number chosen from universal set is a multiple of 3 and find the probability the number is also a factor of 3. This is again a conditional probability, right? They're already saying that you are going to choose a number from set A and it is now this is now an A given. Factor of 30 was C, right? Factor of 30, right? Right, A given C, which is now going to be this one. Probability of A with probability of A intersect C. For A, we had, how many elements we had there? 1 minute. 1, 2, 3, 4, 5. For A, we had 5 elements. And between A and C, we had 2 elements in common. So basically, this is going to be 2 over 5. Right, let me just write this down. For A and C, we had 15 and 3 common. So 15 and 3, we have to use their numbers. But I'm just writing the elements so for your understanding. So 9, 3, 15, 9, 21, 27. Which is going to be 2 over 5. Okay, and that is your final answer now. So this is the working for sets. I hope sets was clear for all of you. And we'll move on to the next question. This is from June 23, 2P. Okay, now over here, the Venn diagram shows the information about the number of students who plays rugby and basketball and hockey. The number of students who do not play basketball is 35. Okay, that is the number of students who do not play basketball. Okay, use the information in the Venn diagram. So use this information to complete the Venn diagram. Okay, the number of students who do not play basketball is 35. Okay, who do not play basketball means that the 6, 10, 3, 6, these are all eliminated, right? We are only going to take this 4, 12, 0 as the total for the students who do not play basketball. So basically n b prime is given as 35 and we can write an equation. I consider that as x for the number of students who just play rugby. That is going to be x plus 4 plus 12 plus 0, that is equals to 35. And now this is going to be x. 4 plus 12 is 16. So x is 35 minus 16. So 35 minus 16 turns out to be 19. So value for x is 19. That means over here you're going to get 19. And after this it says that find out the number of elements in H intersect B. H intersect B, that is 2, right? 3 and 6. So this is going to be number of elements 3 and 6. So it is going to be 2. Wait 1 minute. Number of elements H intersect C. Now over here, to be honest, the 3 and 6 were not actually represented as number. They were representing students, right? That means this one indicates that there are 3 students who take all of the 3 activities, and there are 6 students who take basketball and hockey. That means 6 plus 3, right? Now this time we're going to add them together. So this is not going to be 2 actually. This is 6. Sorry, 1 minute. 6 plus 3, that's 9. Because now 6 and 3 does not represent elements, they represent students. And then again, H union B is what? 6, 10, 6, 3, 4, 12. Right? All of these added together. So 6, 10, 3, 6, 4, 12. So it is going to be 6, 10, 3, 6, 4, 12. And if you add all these things together, you're going to get 41. Let me check. 6, 10, 3, 6, 12, 4. 6, 10, 3, 6, 12, 4. Yeah, 41. And then again, for the last part, they are saying that R prime intersect B union H. Okay, R prime intersect B. R prime intersect B only gives you 10 and 6. Okay, so let me just write this down, that R prime intersect B only gives you 10 and 6. And then from this, you have to union it with H. When you're going to union it with H, you have 6, 4, 12 only. Okay, when you're going to union this with H, so this union with H. Now then it will look like 10, 6. As 6 was already there, I obviously cannot write the repeated units twice. I have to write the repeated elements 1. So 6 was already there, so I'm not going to write 6 again. But then other than 6, we had 3, 4 and 12. So I'll just write those down over here. 3, 4 and 12. Right? And then I'll add the values, which is going to be 10, 6, 4, 3, 12. 10, 6, 4, 3, 12, which is 35. Okay, this is 35 now. So this is the value. Now again, after this, one of the student is selected at random, given that this student plays hockey. Now I am already aware that I'm going to choose the student from hockey, and out of hockey there's again a second condition. Calculate the probability that they also play rugby. Right? And you need to give your answer in this fraction where m and n are integers. This is basically probability hockey given rugby. That is basically hockey intersect rugby out of probability hockey, right? Because I already knew that what the student that I'm taking was already from the state hockey, and out of hockey how many students play rugby, right? So that is basically going to be the intersection for hockey and rugby. So hockey and rugby is 4, 3 out of the total hockey, that was 4, 3, 6, 12. So this is 4, 3 number divided by 4, 3, 6, 12. 4, 3, 6, 12. 4, 3, 6, 12. Okay, and now for this part, 4 plus 3 is 7, and 4, 3, 6, 12 is 7 plus 6, 12. That is 25. Right, so you get the value for m as 7, n as 25. That is your final answer then. Okay, so this question is also done. Let's move on to the next question. Now this is from June 23 2PR question 2. It says that a universal set, and there is set A, B, C, and universal set is P, Q, R, S, T, U. A is P, R, T, and Q is Q, R, S. We need to find out the intersection for A intersect B prime. B prime is basically QRS, like other than that, everything will be inside the B prime element. So B prime set is basically P, T, U, and we need to now find out the intersection between this P, T, U and P, R, T. So we can clearly understand that P and T are common over here, right? So for this part now, A intersect B prime, this is only going to be P and T. Right, this is your element intersections, common elements for set A and B prime. Then again, given that now this is actually like the June 22 paper 2 question, right? We solved this like where we had to find out the possible sets for set C. Similar to that. Over here, now they are giving you three conditions that in set C, there are three elements. Okay, so let's remove all these things. Sorry, let's remove all these things. Now, I already know that in my set C, I have three elements and A intersect C, like there are two common elements for A and C, and there are one common elements for A and B. Okay, now two common elements for A and B. That means if this is two common elements for A and B, for A I had P, R, T, right? So P and R already is present in B also. So P, R is cannot be there. In that case, it would be two common elements with B. That is not possible. So P, R, U could be there, right? That is one of the possibilities for set C, that P, R, U. This one matches with P and R was from two common from A intersect C, and R is one common from B intersect C. This matches with PR, which is basically A intersect C, right, which gives you two elements. This matches with this condition, and then again we have another condition that was R, which is basically the intersection for B intersect C, and that is for one element, right? And then again for your PRU. Now another possibilities could be that mm, PTQ, right? That could be another possibility. PTQ, because PT is again two intersection for A and AC, and Q is one intersection for BC. Okay, this entire thing matches, but the elements will be different. This time it will be PT, and this time they will have Q, PT, Q. Okay, that is your second option. 1 and 2. Let's try to find out if there are any other options available. For example, PR, PT, then again PTS, there could be also one possibility, PTS. So 3 is PTS, right? Where PT, and this time it will have S. PT is basically the common elements for A and C, the two elements, and S for B intersect C, right? Then again for part 4 now, if we go, let's try to find out if there is any other elements possible. PT, we had P, R, then 1 minute. PTS, PTQ, PTR is also there. Then we can take RTU there, right? Yes, last one would be that R, sorry, RTU. From this portion again, we have RT common for A intersect C, two elements, And alright, over here this is going to be RT, this is RT, and this is R. 1 minute, this is supposed to be in red. This is RT and R. Right, if I zoom out, these are the 4 possibilities of set C. I hope this was clear for all of you. Let's move on to the next question then. This is it for this question 2 for June 23 2 PR. Let's move on to this one. This is November 23 2P question 3. Okay, now over here it says that there is a universal set, and inside that there are two sets A and B, and these are the elements for set A and B. We need to find out the A intersection B. A intersection B is going to be what? We can see 11, 12, 13, 14, 15, right? 10, oh wait, sorry, 1 minute. This is not 12, 12, 13, 14, 15. So 12, 13, 14, 15. These are the common elements then. So 12, 13, 14, 15 inside the set notation obviously. When A prime intersect B, A prime means from 7 to 15 everything will be eliminated. So A prime turns out to be 16, 17, 18, 19, 20, 21. Okay, so from this part again, you can clearly understand the 16, 17, 18, 19, 20. These will be in common. So these are the common elements now. A prime intersects C. This 16, 17, sorry, 16, 17, 18, 19, 20. 16, 17, 18, 19, 20. So these are your common elements for A prime intersect B. So 16, 17, 18, 19, 20. Okay. Now after this A union B whole prime. So for this A union B, you can see that A starts with 7, 8, 9, 10, 11, 12, 13, 14, 15 and B continues to 20. Right. That means for this entire A and B, we're actually using 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All these elements are used inside the set A and B other than the starting one 6 and 6 and the ending 121, right? So if I'm going to use A union B whole prime, I'll obviously write 6 and 21. This was quite easy for paper 2, right? This is all November 23 paper 2 and that is the end for the sets part. We're now going to move on to the next section, that is geometry. Now this is geometry Jan 22 paper 2. Now for this part it is stated that ABCD is a circle with center O and EDF is a tangent to the circle at point D. And it is also stated that angle ABC is 86 degree and CDF is 38 degree. The length of the arc AGD is 0.8 pi centimeters. The length of the arc, 1 minute, arc GD, this one they're talking about. This particular arc is 0.8 pi and give reasons, show that the radius of the circle is 2.5, so 1.5. Okay. Radius of the circle is 1.5, right? 1 minute. Now this is quite easy but very lengthy, I would suggest. I mean, for this part I'm only actually focused on this sector OAGD, as I want to find out the radius using this sector, as they have provided me with the arc length, right? Arc length over here for this sector specifically. So now in this part, using this sector, first thing I can understand is that ABCD is a cyclic quadrilateral. That means this angle is going to be like addition of these two angles is going to create 180, right? Angle A and D is going to create 180. So I can write that ABCD is a cyclic quadrilateral right? From this cyclic quadrilateral, I can understand that angle ABC plus angle ADC, that is equivalent to 180 degree, right? Angle ABC is already 186 degrees, so angle ADC is 180 minus 86 degree. That turns out to be 180 minus 86 is 94 degrees. 94 degrees. Okay. Another thing I know that radius is always perpendicular to your tangent. So this angle is also 90 degree. Okay. That means I can easily calculate this portion of the angle. I just have to subtract this 38 out of that 90 to get ODC, right? This is your ODC. This is my ODC angle that I can easily calculate by subtracting the 38 from that 90 degree. Okay, so for that, I'll just write this down over here, that angle ODF is 90 degree because OD perpendicular to DF. Okay, and then again over here, OD perpendicular to DF, and angle ODC is actually going to be 90 minus 38 degree, which is 90 minus 38. That is 52 degree now. Okay, this portion is 52. Okay, this portion is 52 degree. Now I can easily calculate this side, angle OAD. So angle not OAD, this is actually going to be ODA. Okay, angle ODA is going to be what? This total black angle that we calculated as 94. I can subtract this red 52 from this 94 to get this angle OAD, right? ODA, this angle, I can get that. By subtracting the red from the black angle, I can get this blue angle, ODA. So ODA is going to be 94 minus 52, which is 94 minus 52. This is now 42 degrees. 94 minus ODA. Yeah, that is 42 degrees. 1 minute. ODC is 52 degrees. Yeah, this is 42 degrees, right? No wait, 1 minute. 180 minus 86 is 94. That was so totally 94. 94 minus 52 is 42 degree, right? So this is now 42 degree. Now again, if you focus on OAD, this is an isosceles triangle, right? For that OAC, if this is 42, this one is also supposed to be 42. So now I can write, I'll just have to know, let's just make this entire thing to this page, okay, to this side. Now I'll just continue with my work. That now we're going to focus on the triangle OAD. Okay, now we're going to focus on the triangle. In triangle OAD, this is your OAD, this is OAD. For this OAD again, I can write 1 minute. If this is 42, this is 42, right? As they were both the radius, that means obviously angle A and angle D were equal. So I can easily calculate the angle at the center now, which is going to be angle AOD 180 minus 242, right? Now this is 180 minus 242, which is a 96 degrees. So this is 96 degrees. Now I have the value for this angle at the center. I have the value for this theta, the value for this arc length. I can easily calculate the radius now. Now this is how the entire thing actually looked like. 1 minute. I'll actually copy this diagram. Copy, paste. Delete. I cannot delete that. Okay, no, that's not a problem over here. This is how the structure looks like. This is an entirely sector. I can understand that. This is O, A, this point is G, this point is D. And on your exam, on your question paper, it is already given that the AGD arc length was 0.8 pi. This arc length was 0.8 pi. So using the formula for your arc length, you can actually calculate the formula for your radius. Right, let's just do this from the next page because I don't think we will get enough space over here. So now for the arc length formula, it was 0.8 pi and the formula was theta by 360 2 pi r equals to 0.8 pi. I can clearly understand the pi's will get cancelled out over here and these two will get cancelled out over here, so you're left out with what? Let's not cancel this out. The value here theta was 96, right? So this is going to be 96 over 360 multiplied with 2r equals to 0.8. So finally you can write r as 0.8 multiplied with 360 divided by 96 with 2. So which is going to be 0.8360 96 with 2, and that will be 1.5, right? That is what we are trying to prove all this time. So this is your final answer. As I've stated, this is not that much tricky to understand, but this was extremely lengthy. We have to do a lot of steps to get to the value for your radius over here. And that was it for part A. This is all the working for part A. After this, now we are going to move on. Calculate the area in centimeter square to two decimal places of the circle ABCDEF. Sorry, ABCDG. ABCDG. I can easily find out the area this time, right? This is going to be pi r square. I already have the value for r also available. So part B, area is just 1.5 square multiplied with pi, and that will be 7.07, correct to three significant figures. So 7.07 centimeters square. Okay, that is the value for your part B. And this was it for this geometry question. Okay, now the next question is from Jan 22 2PR. So we have this circle. Inside that circle we have a cyclic quadrilateral we can see, and again this angle is going to be the double of this one, because obviously we can understand this is creating your angle at the center concept, right? Exactly after the center, exactly behind the center, it was this 51 degree. So obviously double of that 51 will give you the angle of x, and this is what they're also asking you, to find out the value for the angle marked x, that is just twice of 52, because angle at the center, that is your reason. So for part A, this is going to be twice of 52, angle at the center. Always include reasons, okay? Angle at the center. So which is going to be 102 degree. And then find the size in degrees of the obtuse angle PTR. Okay, PTR, this one. I can easily calculate that. That is going to create cyclic quadrilateral. So 180 minus 51 will give you the angle PTR. So angle PTR is 180 minus 51. So this is cyclic quadrilateral, which is going to be 180 minus 51. 180 minus 51. 180 minus 51. That is 129 degrees. Okay, and that is it. After that, now they have given you this shaded diagram or something. It says that in figure 3, ABC are points on a circle with center O, and such that AOC is 118 degree. This one they're talking about, this angle is 118, and they have also provided with the length that AB and BC are of equal length. And the area of the shaded region is shown in figure 3 as 70 centimeters square. We need to find out the total area in centimeters square to three significant figures of the unshaded region inside the circle. Oh, this time they're talking about the unshaded region. Okay, for the unshaded region, we can easily calculate that. For example, if we are able to calculate the total area of the circle, we just have to subtract the 70 from the total area, and that will give you the unshaded region of the circle, right? Now, for that part, if you focus over here clearly, this portion is actually creating a sector, right? This is actually creating a circle. This is actually creating a sector over here. Now for this sector specifically, I can understand if this is like 180, right? And then again, if they are of equal length, right? That means this portion of the angle and this portion of the angle are equal to each other. So that means angle BOA and BOC are equal. So let me just write it over here. Angle BOC and BOA are equal, and obviously at the angle at the center is 360. So I'll just consider that as x. So which is going to be x plus 118 equals to 360, and x then turns out to be 360 118 divided by 2. So 360 118 over 2, that is 121 degrees. Okay, now using this 121 degrees, I have to find out the value for your radius, because they have given me the value for your this portion only, right? And only the radius is unknown. Using the radius, I mean, if you calculate the radius, then everything will be solved over here. Now for this shaded region was 70. I can understand that this shaded region is basically what? This shaded region is wait 1 minute. Yeah, this shaded region is basically sector minus triangle, right? This entire sector, and you have to subtract this triangle from that entire sector, and that was giving you that shaded region of 70 centimeters square. Okay. I can break down the triangle in terms of radius. I can break down the sector in terms of radius. So let's start with that. BOA. Okay. This is your first working, and for your second working, we're starting with this. Let's copy it from here. Uh, 1 minute. Okay. Okay, I'll just take it over here. Now over here, this is B, O, A, and these are the radius, right? And then again over here from this triangle again, I can make a triangle. Okay. Now this is your triangle, right? I can write the equation for your sector in terms of radius. That is what area for sector is actually theta. I calculated this theta to be 121. This is 121 degrees. So theta by 360 multiplied with pi r square, right? And then again I can express this triangle also in terms of half pi sine theta. So half sine theta a into b, right? A into b is over here is again radius b o a, and this is 121, right? This is what 121 360 pi r square, and this portion is half r multiplied with r and then sine 121, right? Now over here this is going to be what? Sector minus area. So a triangle. That will give you that 70 centimeter square shaded region, right? So sector is 121 over 360, sorry, 360 pi r square minus this one is again half sine 121 multiplied with r square, right? That is equals to 70. Now over here, I can take this r square common, and that will be equals to 121 over 360 pi minus half sine 121 degrees equals to 70. From this part, I can understand I'll just have to take this entire part to the right hand side, and that will be divided with 70. So if you could just make r the subject of this equation, so this is going to be r 121 360 multiplied with pi, and this will be subtracted with half sine 121 degree, and everything will be inside a root. If you just get this entirely on your calculator, that will give you the value for your r, which is now 121 divided by 360 multiplied with pi, and then again, sorry, minus, then again you have half sine 121. This gives you the radius as 10.563. Okay, the radius turns out to be 10.563 centimeter. Now you have the radius, right? So in order to find out the unshaded region of your circle, unshaded region, this is going to be what, pi 10.563 whole square minus 70, and that will give you answer as 281 centimeter square, right? This is your final answer now. This was, I think, for part B, right? So this is for part C. The entire working is for part C. I hope this entire geometry concept was clear, and in this entire file we tried to complete with sets, probability, geometry, then we continued with what was the other topic? Sets, probability, geometry, trigonometry, mensuration, right? So all of these concepts where we discussed as with as much detail as we could. So I hope your exams for your paper 2 would be good for tomorrow. And if you guys are interested for any of the crash courses for IGCSEs and for A levels, please let me know through WhatsApp or by email. Another thing, we have A levels IT, right? A levels IT available now, and all of our trial classes for A levels are starting from June 20th. So if you are interested to join our AS A level trial classes for May 2025 session for the physics, maths, and IT, then please inbox us in our WhatsApp and email address. If you think that only our revision videos are helping you this much for your last minute of your exams, then think about how our entire year-long courses will try to help you and explain you the entire basics for everything that will be related to your exam papers. So give us a chance and join our classes, join our trial classes. These are extremely free, entirely free. So I would suggest join our trial classes, and then you can decide if you want to continue or not, right? So thank you so much for watching this entire all long videos, and all the best for your exams tomorrow. If you still have any problem, do not hesitate to reach me out through either WhatsApp or email or even in the comment section. Thank you so much for watching these videos. Bye bye.